Okay, so you are in the view, so you should be human. You can go. Yeah, you can see it here if you like.
Yeah, I see it on the screen
Okay,
here.
great.
So basically,
okay,
if
you are
stay,
on the left edge right now. So
yeah. Basically, if you stay near this red box
So here?
on the screen, that's the perfect place.
Okay, I'll be here then.
You can go here.
No, so
maybe
good.
at the middle at most.
Good.
And there,
I'll stay here.
Good morning, everyone. Welcome to the first talk of the final day. Before the talk starts, I would like to remind you that today we will have a final session or win-win show session that Radek will be handling. I think it will be in this the big room, right? Yes. So please come there. Stay until the end of the conference. There are still a lot of things to enjoy. With this, I'm passing over to Ricardo on automating Kubernetes with event-driven Ansible. Please welcome.
Good morning. Thank you. Good morning, everyone. Welcome to this talk. So first, an introduction. I'm Ricardo Correa Cruz. Everybody just can call me. You can call me Ricky. Everybody calls me Ricky. I'm a principal software engineer at Red Hat. I've been at Red Hat 6 years and a half. I'm a member of the productization team of Ansible. We're responsible for building, delivering the various components of the Ansible automation platform, and we're also involved into some other offerings in cloud and whatnot. And we're also responsible for the installers and the operators for Ansible. Previously to that, previous company, HP, I was working heavily in OpenStack. I was part of the infra team, both upstream and downstream. Then I joined Red Hat Ansible Engineering, did networking, CSD, cloud stuff. Then moved on to OpenShift Engineering, doing networking. Then moved on to the office to do some telco stuff, and back to my mothership, Ansible, and I'm very happy about it. So I've shuffled around quite a bit. So first, super brief introduction to Kubernetes. I assume that you know what it is, but just mandatory slide. So what's Kubernetes? It's an open source platform that orchestrates containerized applications. So you have your containerized applications, and you declaratively put a manifest. I want to run this application with this many replicas, and want to expose this port. And Kubernetes does its magic, and make sure that they get run and all the things. Developed by Google, now a CNCF project, so we have a lot of contributors, Red Hat included. We have a lot of people working on it, essentially because we have the OpenShift product, which is Kubernetes distribution. There's a wide ecosystem of tools and projects around it. If you go to the CNCF landscape, you will see this massive picture of observability, monitoring, provisioning, all sorts of different use cases that are around Kubernetes. So it's a big thing. You can either run it on-prem or hosted in clouds. You have Kubernetes in AWS, Azure, Google, Linode. We have a Red Hat OpenShift in all those clouds. You can also run it on-prem. At its core, Kubernetes, it allows you to self-heal your applications. So make sure that it will be always running. If for whatever reason it dies, it will bring it back up. It allows you to do scaling, horizontal scaling. And it also allows you to do running updates. So if you update your application, it will do zero downtime update, and you can also do like a rollback. So when you adopt Kubernetes, they're typically like what they call, I'm not an architect, but it's like a known term or pattern. It's like they call it like in day phases. So typically in Kubernetes day 0, you gather the requirements for the workloads that you're going to run in Kubernetes, how are they going to run, whether where is going to be your data, is it going to be on-prem, can it be on cloud, will you be having like hybrid cloud Kubernetes, like on-prem and on cloud, how you're going to connect that to your environment. So in this phase, you do all that, requirements gathering, the design, and the architecture. Once you have that, then you move on to the next day, which is installing the cluster. So you install the cluster, so you probably have some Ansible playbooks or Terraform or CloudFormation or I don't know, ARM templates, whatever you're running and installing your cluster. You install it, and then you configure it. You put the initial users. You probably hook it up to your infrastructure as code repositories with your CSD, and that's the initial bootstrapping of the environment, so to speak. And then in day 2, that's where you deploy the workloads, and then you do the ongoing maintenance of the whole applications and the underlying infrastructure. So this is where You take care about observability, so you monitor your applications, you monitor your infrastructure. Is it sane? Is it like maybe is it performing well? Not that kind of thing. Then you take care about the scaling. Maybe your workloads grow over time, and you need to scale the nodes. So that's something that you have to do in day 2. So how are you going to do that, right? Security. Through RBAC, new users coming in, users coming out, maybe contractors. How you're going to handle certificate management, secrets rotation, that kind of thing is what you do. Storage, same thing. So probably, you will run out of space at some point. If you're on cloud, maybe it's taken care for you by the underlying cloud provider, but maybe you're on-prem, so you need to, how can you expand the storage so you can, still run your business applications. Networking, imagine that you have like a initial CIDR for your cluster, and then you run out of IPs. How can you expand that, or how maybe you need to interconnect to some other internal site? That's another thing you do in this area. Update management, both from the applications point of view and the cluster. Inevitably, Kubernetes is like a fast-paced project, so new versions come out, and you may want to keep up and update them. Disaster recovery, backup and restore of etcds, volumes, databases of the applications. Do you have a strategy for that? How can you back up? How can you restore in case of a total disaster? How can you bring up a mirror cluster environment, or maybe you have a pilot-like environment there, and when there's a recovery, you can quickly bring it up. That's the kind of thing that you do. So in Kubernetes Day 2, you have tools and practices for doing that. Typically within workloads of Kubernetes, you use Kubernetes operators. So they're like Kubernetes native applications that contain the operational knowledge to maintain the life cycle, manage the life cycle of applications. So typically, if you have a PostgreSQL that you use in your environment, you have a PostgreSQL operator that will do the installation, but will also take care of the backups, restore, upgrades, that kind of thing. You probably want to use GitOps to manage and deploy application infrastructure, so keeping Git declaratively the configuration for both your underlying infrastructure and your applications, and have that system to automatically apply the application, so no human intervention, hopefully. And when you're done, for the things that don't fall into the 2 previous buckets, you probably have like runbooks that define day 2 processes. So best case scenario, you probably have like Ansible or Bash scripts to automate that. Okay scenario, you will probably have a GDoc or some wiki space somewhere. Worst case scenario, you hit an issue and you just try to figure out and fix it. So now I'm going to talk about Ansible. I assume that you probably know Ansible, but I don't like to presume things. We'll be quick. So Ansible is an IT automation tool. It allows you to automate tasks in your infrastructure. It's open source. That's what we do at Red Hat. It came via an acquisition. It's very easy to learn and use. It uses YAML. The learning curve is really, really easy. You can get going, fairly quick and automate things. It's agentless, meaning that for the things that you want to automate, be servers, network devices, firewalls, cloud endpoints, you don't have to install anything on the target. You run your automation from a Bastion control machine, and you perform the automation against those targets. Highly extensible with plugins. Everything is plugging in Ansible, so it's very extensible system, and you can swap in, swap out behavior by changing plugins. Use cases, configuration management, so create users, install packages, systemd services, power rules, that kind of thing, and servers. Infrastructure provisioning, so we have modules for provisioning pretty much everything, like for AWS, Google, GKE, Azure, VMware, OpenStack. There's also stuff for bare metal provisioning. Application deployment, you can use Ansible to deploy containerized applications or legacy RPM applications or dev even. Orchestration, this is my favorite. since Ansible is so easy to learn and it has such a wide integration with pretty much every system you can find in an IT environment, you can use it as a glue, as a universal automation language to orchestrate all that. Hybrid cloud, as we said, if you have public cloud stuff and on-prem, you can just use it to interconnect them. Networking, this is a big one. So Ansible has a wide variety of modules for managing networking devices. As a matter of fact, we have like a content team just for that. So the Cisco's, the Aristas, the Junipers, you can manage that. Same for security. We have modules for Palo Alto, Checkpoint, CM systems, IDS, that kind of thing. We're also getting a lot into Edge. There have been like quite a bit of talks this week about Edge automation, so we're getting into that area a lot. So how it really works. So you have a control machine, which is a bastion, which is where you install Ansible, and that's where you run Ansible from. And then you have your target nodes, which is your servers that you want to automate, or maybe your network devices, or your security appliances, or your cloud endpoints. Then in the inventory is where you keep your authentication and connection details on how to connect to those target nodes. And then the playbook, which is the artifact in which you define the things that you want to automate. Typical inventory static file, very easy to read. Here we have a databases group with that IP and a web service group with 2 IPs, meaning that if I run a playbook against the databases group, it will run the task against that IP. Run automation against web service, it will run the task against those 2 IPs. Fairly simple. This is a playbook example. Here we have the host, so we're targeting the web service group from the previous inventory file. We're telling, hey, we want to use like root to get into those machines. And the task, which contains the automation itself. So it's going to run sequentially this task. So in this case, as you can see, it's fairly simple. It will install the HTTPD package with Yum to the latest version. Then it would templatize with Jinja the config file. So Ansible, so that's like, from a generic point of view. So then, if you drill down, you have like other components or other abstractions. So the modules contain the code to perform a particular task. So there will be a module for typically a Python for containing the business logic for this task, for each one of the tasks, you will have like a module for doing the thing. They're mostly written in Python, but any language can be used, providing that a module really just needs to like read JSON and output JSON. I mean, how it does it, internally, it's not really, important. I've seen, modules done in Bash, even in Golang, so they're easy to develop and ship. So you don't have like to have a module in your system libraries for Ansible, or push a PR and hopefully it gets merged and then it's in a release. You can develop a module, put it into a library folder alongside your playbook, and Ansible will auto-detect it and use it. So, which is nice because it allows you to get going and also test modules easily. So Ansible has built-in modules. So whenever you see Ansible.builtin.whatever, so those are built-in modules. So they're part of the Ansible core package. So it's something that you get, bundled and built in with that RPM package. There are also Ansible content team modules. So we have content team within Ansible for networking, cloud, also security, I think, and also people doing Edge stuff right now. We also have partners doing modules. So some other like I don't know, vendors from all kind. They also have like their modules, and they develop and maintain them. And you also have community modules. We have a great and vibrant community, and we get a lot of contributions there. So once you start, doing a lot of your playbooks, you will start realizing that, you can maybe refactor and reuse that automation for other environments, not necessarily tying that to a specific host of your inventory. So that's when you use roles. So roles allows you to encapsulate Ansible contents such as tasks, change of templates, static files, variables, to automate a particular thing. So you typically would have a role for I don't know, Nginx, for Apache, for PostgreSQL, and that's self-contained and can be reused in whatever environment that you have. Once you have a role created, the way you use it, then you include it or import it in a playbook as a task. So you would do include role, my role, and it would include it and run the task within your play. So that's the typical structure of a role. Here we have a common role which contains a task folder, a main YAML, some Django templates, static files, some vars that are specific to the role, and some defaults in case you don't have, you don't specify the vars on command line or in the playbook. There are some other things, but these are like, the most common ones. You also have like handlers and some other things. You can also, you used to be able to ship plugins, but now, with collections, which we'll see in a moment, that's not anymore, a thing for roles. So plugins, as we said, extend and modify core Ansible capabilities. There is like a large variety of plugins. You have connection plugins. So typically, when you use Linux and you run your automation against Linux, it's going to use the SSH connection plugin. But maybe you have Windows machines. So Windows is not usually SSH is not something that you usually use in Windows. So there's a WinRM connection plugin. For networking devices, there are like NetConf connection plugins. So it really allows you to extend and to adapt to different kind of devices and things that you may use in Ansible. They're easy to develop by using Python. These ones you have to use Python. I don't think you can use other language. Okay, so now you have playbooks, you have plugins, you have roles. So how can you package that up? So back in the day when I joined, so we had Ansible, and we shipped all the modules, all the plugins and everything within one repo. Then that became, hard to maintain and hard to contribute because, we only had, certain bandwidth to review and get things going. So there was a decision to decouple. So I have Ansible core, as I talked about earlier, to just contain the core of Ansible, the binary and the built-in modules, and then the rest have it in a separate artifact, which is called a collection. So we're happy in collection contain playbook, roles, modules, and plugins. So they're typically like for domain automation. So you will have a collection for AWS, collection for Azure, for Arista, and those collections will contain all Ansible things for automating that particular domain. Distributed by Ansible Galaxy Private Hub. You can just go to Ansible Galaxy. It's like the content store for Ansible. You can just go to browse for content and download it and install it in your machine. You can also have like a private Galaxy, which is called a Private Hub, to install that. So for Kubernetes, it's no exception. So there's a collection for Kubernetes, which is called Kubernetes Core Collection. It contains modules and plugins for automating Kubernetes and OpenShift, since OpenShift is Kubernetes. You install it via Galaxy. Ansible Galaxy collection install, Kubernetes Core, you install in your machine, and then you can use that content. So this is a subset of modules that are included in the collection. So you will have modules for Helm. Helm is a package manager for Kubernetes. It's like an RPM kind of thing. It uses something that they call it chart, which is like a definition for an application. So you can just, instead of using Helm, you can just use this module. It will use it under the covers. Then we have modules for managing Kubernetes objects. See, this is probably the most used one, the K8s module, because it allows you to either slap into the module as parameter the definition for an object, or you can also specify a Kubernetes manifest that you may have, meaning you don't have to redo your Kubernetes manifest in the Ansible DSL. You can just reuse your Kubernetes manifest and just use it. You can exec into pods, get information about Kubernetes objects, log pods. You also have imperative modules like rollback and scale, not only declarative. Some other specialized like service modules, which are probably not super useful because you can do the same thing with the case module. This is an example. So here we're using a Kubernetes manifest that is within testing deployment YAML. This is a Kubernetes manifest, and we're telling, hey, apply this manifest, and we just do it. That's why I said that it's good, because you don't have to use the Ansible DSL. You can just reuse your Kubernetes manifest. You don't have to change anything in your environment. Here another example using an imperative module. So here we're saying, hey, the elastic deployment, which is under namespace my project, I want it to be 3 replicas, and it will do that kubectl apply to have that replica set. Okay, so what's EDA? So it's a new Ansible project that allows you to execute automation based off of events. So what it is? It allows, typically in Ansible, okay, you have a playbook, and you want to perform something. I don't know, maybe you want to do a backup, and there's a human running a playbook, or something happens and something opens you a ticket. Hey, I need to do a restore. Then you run the restore playbook. So what EDA allows you is to automate that trigger of that Ansible automation. You can think of it as the if this then that of Ansible. So basically, with EDA, what you do is you observe events from your environment. Then, when those events trigger, you evaluate those events against some rules which you define. And then, if there's a match, then you run some actions. So EDA uses an abstraction or a concept that is called a rulebook. You probably, hey, yeah, it's like a playbook. Yeah, so it's a rulebook. It's the playbooks for EDA. So rule probably gives you a hint what they're all about. So rulebooks contain a set of uniquely named rule sets. Then within rule sets, you have a host section, which you define what you want to target for your automation. The sources you want to listen, so what kind of the events you want to react to, and the rules to evaluate those events. Then the rules themselves contain conditions and actions. So, and then if the events match the conditions, if there's a match, there's an evaluation that is performed by the Jules engine. It's a Java-based engine for rules. Then the rule action is executed. Rather than me trying to explain things abstract, let's see a rulebook. So here we have a rulebook called Hello Events. It contains a host section, in this case localhost, and has sources sections, which this is where you put your event sources plugins. So here it's Ansible EDA range, which I go through it in a moment. Then you have the rules, which have this one rule called say hello with a condition and an action. So in this case, the event source plugin Ansible EDA range is kind of a test event source plugin, which basically does a Python range. So it will go from 0 to 5, and it will create an event for each value. So there will be an event for 0, for 1, for 2, for 3. Then, as a rule, we want to catch when the event.I, the key I within the event, is 1. And when there's a match, we will then run this playback. This is probably not super, fancy, but probably in this next thing you will probably see, what we can accomplish with EDA. So in this case, we have another rulebook. Check my web app. We're targeting all the machines on our inventory, and we're using the URL check event source plugin. What it does, it will pull for the URLs that we have as a parameter continuously. You can put that delay or timeout value for when you want to do that check, and it will return back the status code, 200, 400, 500, whatever. So here in the rule, it's called health, and we have in the condition, hey, trigger it when the status code is different to 200, and then run a playbook which is called restart app. So basically, this is a rulebook for self-healing, remediating a web app. So this is the kind of thing that we can do with EDA. So in the rules sections, as you can see, we can have like multiple rules, not just one. It's like a list. Within each rule, you can have like multiple conditions. You can have like checking various things within the event, so different fields, compare against different values. each rule can have like multiple actions. So when there's a match for a given rule, you can have like a list of actions and they will be executed sequentially. Although I think they put a patch recently which you can have like run actions in parallel. I need to get back to it and check. So the rule conditions is like a Python Boolean expression. It allows to put like Boolean operators, arithmetic operation, and is. So you can do things. Does my event contain this key, or is this key within my event equals to this value, greater than, less than, that kind of thing. You have and or not, the usual that you would expect for that kind of expression. It can contain multiple conditions. You can have like a list of conditions, and you can also use like any all operators to say, okay, if there's any of the condition matching the event, then execute the action, or whether you want to have like all of them to match in order to get down to the action. So the final part of the actions are like in the final part of the event-driven flow. So that we have event, we have the evaluation of the rule for the event, and then if there's a match, that's the action. So that's like the final part. We define the execution part when the event is matched by a rule. So when there's a match, then you run the action. You have like a built-in set of actions bundled with EDA. Event source plugins, they're like separate from the EDA core. Actions are like bundled within the binary that EDA uses. There are no plugins right now for actions, but I think they're open to bundle actions as part of separate content. So probably will be implemented down the line. These are like the actions that you get built in from EDA. You can run a playbook, as we saw in the examples. We can run a module. This is like the same when you do Ansible all-m ping. Imagine that you want to do like a quick execution with Ansible. You don't want to create a playbook for just one task, and you want to specify the module and the parameters in a one-liner. That's what you can use with one module. Run job template. So maybe you have a WX automation controller somewhere containing your inventories, your job templates, and all your automation. You can hit that controller, AWX, and run automation from it. You can create facts just like in Ansible, post events. So maybe you want to have like a flow of different events, like in a flow chart. So you hit an event and then you want to jump into another event. So that's something that you can do with post event. You can also retract paths, from the rulebook execution, pull it out. Print event, which is just for debugging. And shutdown, which I think is for restarting rulebook if something goes wrong, or you want to restart it for whatever reason. So we saw event source plugins. They contain the business logic for the sources. So for the URL check, there will be a Python thing for doing that. For the EDA range, there will be a Python thing for doing that, and for more interesting things, which we'll see in the next slide. They are Python files. They use the async IO library, so they are asynchronous. The plugins can be either polling for external sources, or they can also be listening in a port. So an external source can send events to the plugin, and then it reacts. Once it catches the event, it puts it into a queue that the EDA runtime gives it to the plugin, and then it can evaluate it with the rules engine, and then depending if there's a match or not, run the action. So how does it really look from internally a plugin? So this is like the meat of the URL check event source plugin. I'm not an SAKIO guy. I've got it in Python Iowa, but it's not hard to read. It's an infinite loop in which it gets a session with HTTP, a client, and then it tries to, for each one of the URL that you pass as a parameter, it will try to hit it. And it's going to get the status, and then it's going to put it into the queue as a dict. So then it can get evaluated by the rules engine. So what are the event source plugins? So right now we have like the one official one that we the EDA team maintains and develops, which is the Ansible EDA collection. They have like a bunch of different plugins. These are like the most, it's just a subset. So you have like event source plugins for Kafka, so you can actually get events from a Kafka queue. Also from Alert Manager, which is a companion service for Prometheus. Prometheus getting metrics, then Alert Manager alerting when the metrics go over or below a threshold, and then you can trigger automation from Alert Manager. CloudTrail, one of the services for AWS for security that keeps a log of the API calls for a given account. SQS is like a messaging system. It's also very very handy. Azure Service Bus, same thing. Webhook, this is a good one because it's a generic webhook event source plugin. This is like a listen event source plugin, so it's going to listen in a port, and you're going to have external systems send webhooks to the port and then react to those events. So along the Ansible EDA collection, so we're getting partners developing their own Ansible EDA collection. So those are some things that have been announced. So CrowdStrike, a security vendor, they're developing their own for the product. Cisco for the NXOS devices lines, and the ThousandEyes, which I think is a monitoring product line. Dynatrace, an APM. IBM Instana, another APM. Turbonomic, I think, is a cost management system. Palo Alto, security vendor. F5 networking security vendor. Zabbix, monitoring solutions. So they're developing their own ADA plugins. So then you can also you will be able to integrate, if you're using it in your environments, to integrate with that. Besides event source plugins, you have event filters, which allow you to filter data from events. So at times the event from the plugin can be really big, and there may be information that you're not interested. So they allow you to remove or transform the events. You can chain the event filters. Imagine a Linux pipe operator, so you can chain them. And they define after the source definition. They like a per source object. Built in, you have a JSON filter, event filter, so it allows you to include or exclude keys from a JSON, convert dashes to underscore to because maybe you need like a snake case, insert host to meta if you want to search some host as part of your rule activation to the event, normal keys. This is also something that you can develop like event source plugins and bundle into your EDA content. Speaking about just EDA content, how it gets distributed. So EDA content is going to leverage Ansible collections framework and tooling. So meaning you're going to have like Ansible EDA rollbacks and event source plugins and event filters using the collections framework. So you'll be able to just use Ansible SC collection install and you put your collection, it will install it. You can also publish it with this thing, and it will be able to publish into Galaxy, just like an Ansible collection. So as we said, the Ansible EDA is the first EDA collection available. Is the one that bootstrap the project. Now, let's go dig deeper. So what are the components? So the main component right now for EDA is called Ansible Rollback. It is the CLI and worker component for event-driven Ansible. You can either run it in a standalone mode, so you can run Ansible Rollback. You provide an inventory, your rulebook file, and it will run in the foreground. Or you can also run it in worker mode, provide an ID and a WebSocket endpoint, so it can connect to a WebSocket and to get what rulebook should I be using. This is what's going to use largely for the EDA controller server offering. So the EDA team is working on the same way with Ansible. We have the automation controller, which is a central console containing your automation for Ansible. There's going to be an EDA server containing your rulebooks. You can log in, log out. You will get logging about your events, and it's a web application, so to speak. So the worker mode is what gets used. So rulebook connecting to that system. So how we can, so we've gone through Kubernetes, Ansible, Kubernetes content, EDA. How can we mesh EDA with Kubernetes for doing things? So Kubernetes clusters can emit events for changes. So the API server is constantly, every single component in the Kubernetes system is hitting the API server, is the one that is responsible for performing change in your cluster. So when you create a CR, deployment, and config man namespace, it can create things, it can update the prod operations, right? Now the cool thing about Kubernetes API, it allows you to put what they call it a watch. So a watch is an API call you can put for a given resource version. So you can basically say, hey, I want to put a watch for config map objects under this namespace. And then the Kubernetes API is going to stream me back any kind of config map changes in that namespace, whether there are new ones, config maps are updated or they're deleted, I'm going to get those events. So given that kind of functionality, that's what we need an event source plugin for. We need to plug into that capability from Kubernetes for getting watches. So get events from the API and then so we can react to them. So there's an event source plugin for Kubernetes. It's called Saber 1041.eda. It's a collection that was written by Andrew Block. It's another fellow Red Hat. I think he's around. I haven't met him. If you're interested, try to reach him. He wrote it. As a matter of fact, he also published a blog post about the EDA collection, how it gets used. So how it works, it uses Kubernetes libraries, the event source plugin. So with this event source plugin, you define which resource you want to watch. I don't know, maybe API version v1, config map, namespace foo. And then it connects to the Kubernetes cluster and puts a watch against that. And then the plugin gets events from that watch. So that's one way of getting events from Kubernetes. Or you can use the generic webhook, which it's already bundled within Ansible EDA. The webhook plugin is a generic event source plugin that receives webhook events. So it's an event source plugin that listens on a port. And you can get external systems sending webhooks to that port, and then that's the plugin will get the events in that way. So as you can imagine, so we're gonna need to have something, because Kubernetes cannot just do it itself. We need to have something to do that watch mechanism for whatever resources we're interested in, and send those events as webhooks to our plugin. So this is what we can use. Robusta DevCube Watch is a tool that was developed by Bitnami. It's a CLI tool which basically you create a config file and you say, hey, I want to get the watches for deployments, config maps, nodes, whatever. And then for those events, send webhooks to this endpoint. So what we can do, we can have KubeWatch running, hooked up to our cluster, sending webhooks to our event source plugin, running webhook on their port. So now we're going to do a demo. I don't know if this is going to be a hard one because I don't have a mirroring. I'll try my best. So,
Can you increase the
yes.
font size? Yeah,
Is it good?
that's better. Okay.
So here, this is my laptop. So I have a kubeconfig. So I have a cluster, okay, and I can just run kubectl commands. So here I have KubeWatch with a config file, which is kubewatch.yaml. As you can see, it's a YAML file which you specify the webhook section. Okay, so for the events, the watches that I put against my cluster, where I want to send those webhooks. So I'm sending to my machine port 5000, which I'm going to have my event source plugin listening for events. And then for resources, I can put the kind of resources that I want to put a watch. So in this case, We want put watches for deployments, config maps, nodes, and I think namespaces. Okay, so if we run it, it's on the foreground, and it puts a watch for those resources against my cluster. So whenever there's something happening for those resources in my cluster, it will pick it up and send to a webhook. So if we, as an example, so if I create a namespace, Ricky test, okay, and if I go back to the cube watch, it got, processing that to namespace Ricky test, so it got that event, and it tried to send to 5,000, but there's nothing, listening. So what we want, that's because I don't have the event source plugin rulebook, Ansible rulebook with the event source plugin for webhook on that port listening yet. So let's do some cool demo. Let's imagine that we have users using our clusters, doing deployments, whatever, and there's a certain image and tag version for that there's a CVE, or for whatever reason we don't want any users to deploy it in our cluster. So what we want to catch whether there's any kind of deployment using that into, in this example, the default namespace. We want to catch that. If it's using the bad image, we want to scale it back to 0, so it doesn't run on our cluster, and we want to notify to some Slack that I have and post a message, hey, someone tried to do this, don't do it, okay? So if I go here, I'm going to show you so this is real rulebook. So using the webhook event source plugin, listening on port 5000, and we have one rule, which is name and scale down by the image deployment. What are the conditions? So get events that the kind is a deployment, and whether the reason for the event is created. So basically we want to get kubectl create deployment. Now the thing is that the event itself doesn't give us the information about the image being used, so we will need to do some introspection based on the name of the deployment, and that's something that we will do as part of the playbook. So when the condition is met, we're going to run this playbook, scale down by the image deployment and notify, and we pass some vars, my Slack token, the deployment name, which comes from the event, so we can do that introspection within the playbook, and my Kubernetes API token, so I can do the scale down, okay? If we look, the playbook that corresponds to this rulebook, so here we have some var that's called bad image, with is nginx 114.2. So that's the bad image that we want to detect. So if there's a deployment using that image, we want to scale it down, notify. Okay. So what the playbook does, by leveraging the Kubernetes modules, this is why Ansible is so powerful, because it can integrate with everything, and it's really a great glue for your automation. We're going to introspect the deployment, and we're going to register into the deployment variable. Then I have a block. So a block is, you can group task for a given condition, or a variable expression. So meaning when the deployment that we get earlier, if we drill down into the JSON, because that's a JSON, so this gives us the deployment object, okay? So we will introspect it, so we'll get into the pod template of the deployment. We will check for the container whether it's using the bad image, and if it's the same, then we run the task within the block. And the task within the block is using the case scale module. So, set the replicas to 0, and then notify to Slack that, hey, someone is using the bad image, so I have to scale down the deployment, please do not use it. So, if I run the rollback, which is this one. So now I have rollback, listen on port 5000. I have KubeWatch, so getting events from Kubernetes, and for whatever events it's configured to, it was sent to port 5000, which is where we have EDA listening on. So if we go to another session, here I have a deployment manifest, okay? Which creates an Nginx deployment, 3 replicas, and it uses the bad image, Nginx 114.2. So we want to catch that. So if I apply, as you can see, rollback got triggered and it's running a playback. So if I switch back quickly and I do an OC get deployment, oh, it was quick enough. So it created a deployment, 3 replicas, but we catch that event and we scale it back down to 0. So we were able to remediate the thing in our cluster that we care about and we don't want to happen. And if we go back to here, hopefully I can see the. So this is my Slack. Yeah, so it's 10:16, right? So let me. So we got the Slack notification on our Slack about what happened, and we scale it down. So I hope that you can see, how we can leverage all this, because we can build that by using all the integration that we have with Ansible. We can react to events from our environment, whether it's at the in-cluster level or at the underlying infrastructure where our cluster runs, and we can run automation for it. And that's the end of the talk. That's what I have. Any questions? Anything that is not clear?
Okay, I was on the Lightspeed talk yesterday. Can I create with Lightspeed these events as well?
Yes, as a matter of fact, I know.
Could you please repeat the question?
Yeah, so someone asked, Radek asked in the audience if there's a way to integrate Lightspeed, which is an AI assistant for writing playbooks in VS Code and assist you for writing automation, to integrate with that. For sure, because Lightspeed has an API, so you could create an event source plugin or some automation, and plug it. As a matter of fact, I know that there's some people within my team that they're looking into integrations of Lightspeed at EDA, because if you can get suggestions about how to remediate. Imagine you get an error in your cluster and you have no runbook or automation for it. If you could hit Lightspeed API and get a suggestion for a playbook to remediate that, that becomes extremely powerful, right? So that's a great question.
Are there any plans to get EDA into AAP?
Oh, there is. As a matter of fact, so my team is, no, not my team. So my team, we've been developing an operator for an EDA controller offering. So the same way you have AWX or automation controller for Ansible. Ansible, it's just the single tool for running playbooks, but you have AWX automation controller as a central console for running your automation. There's going to be a product EDA server controller, which is the same thing for EDA. So you will have a central console, which you can have users logging in, logging out. You will be able to upload your rollbacks, see your activations, your event data, that kind of thing. I want to also say it's rather novel and young project, we'd love to get contributions and people involved in the project, especially as you can see, the answer would be yes, it contains event source plugins, but the sky's the limit, right? Ideally, we would like to have, it would be nice to have event source plugins for integrating with whatever you have in a typical IT environment, whatever cloud, whatever SaaS you use, whatever. So if you want to contribute, by all means, I mean, the DA team will be happy to look at your PRs and contribute with them. And as a matter of fact, we've already got some contributions. There was another talk the other day, Alex, I think is the guy. He contributed an MQTT plugin, which is really nice. And if you want to be involved, would be happy to hear from you. Okay.
Thank you. We don't have any questions from Matrix, so that concludes this session. Thank you very much.
Thank you.
1 minute before we start. I would like to remind you that today is the last day, and there is a final session, I think it's around 5 or so, that actually will be a win-win session. So please come to play a game and win something in that game. That will be in the big room next to us in the next building. With that, please welcome Nikita, which will be talking about Red Hat Core OS on the mainframe.
Yes,
Is
not
that right?
exactly. Yeah, that's I.
Okay, please welcome.
Yes, so hello everyone. My name is Nikita. I work at IBM, and today I would like to present you IBM Secure Execution for CoreOS and OpenShift. So, before we start, let me ask you 2 questions. Please raise your hands if you're familiar with CoreOS and Ignition. Okay, not everyone. And second, please raise your hands if you don't fully trust cloud providers. Yeah, so I have to explain about what CoreOS and Ignition is. So CoreOS is a small operating system. It's efficient, secure, and designed to run containers in cloud environment. And Ignition is a configuration tool for CoreOS. It runs in init-ramfs time and takes care about system configuration. So you have your config, you give the config to Ignition, and after installation or provision, you have your own CoreOS instance. So it's tool used for configuration. Okay, what secure execution is? Maybe it's some kind of top secret place with one PC inside. No. Secure execution is hardware-based technology developed by IBM, and it's available since Z15 or Linux 3 generation system. It's technology which fully isolates virtual machine memory and CPU state from hypervisor and other VMs. But why do we care about security, and what kind of security we use on daily basis? Mostly everyone. So the most simple example is a phone. So a lot of people use Touch ID or Face ID. So even if phone is stolen, bad guy cannot unlock it and see our messages, photos, or something like that. For similar reason, secure execution exists. It enables the notion of secure VM or confidential VM. So confidential VM is VM where you cannot see what's in runtime in memory of VM. Hypervisor don't have any access to it, or it's blocked. Secure execution not only enables this notion, it also helps you to deploy your VM securely. So you don't trust your cloud provider, but you have your VM. So you can send it as a file and run it. Secure execution guarantees that your VM is unmodified, or if so, it couldn't be executed. Also, it makes it possible to specify on which exact Z mainframes your VM can run. So now let me explain a bit how it works in general in any Linux distribution. So SUSE, Red Hat, Ubuntu. So during manufacturing, each mainframe becomes a pair of host keys. So here are 3 mainframes, and private host key is stored somewhere in hardware. Firmware doesn't have access to it, it's only available by hardware. Public key is published on IBM website, so if you have serial number of mainframe, you can fetch corresponding key. Then we have a special tool called genprot image, which creates a unified kernel image. We call it SD-boot, it's here in blue color. So it's a file encrypted with one or several host keys, which contains kernel, init-ramfs, and command line. So once created, this file can be only decrypted on corresponding machine or machines and run only there. Any other Z cannot run it. Yeah, but is our VM now secure? Actually, not at all. We still have to encrypt the disk itself with LUKS encryption, and there is a headache of system administration, because every kernel update we have to run genprot image again, create new SD boot, and using ZIPL tool, which is IBM's bootloader, you have to install this file onto disk. We don't use grub, we use ZIPL, so there is a special tool which creates a mapping on a disk and you start directly on a disk. So all I mentioned is good for security, but it's not ready for cloud because administration, LUKS encryption, a lot of handwork, it's not acceptable. So at IBM we set 3 main goals for OpenShift and CoreOS. First goal is security must work from the beginning. There should be no gap between you run your VM and you enable secure execution. Second, user experience shouldn't be different or shouldn't differ that much, because if you have to read 10 pages of manual how to enable it, it's not good at all. So people are used to something, they don't want to see huge changes. And third goal was to protect ignition config. I'll get to it soon. So why ignition config is important? CoreOS image itself contains operating system, but without any user, nothing. So in ignition config, you usually specify your user, SSH keys, password, systemd units, actually a lot of stuff you can create. And it's your secret. We want to protect it. So in order to reach those goals, we modified building system of CoreOS. It's S390X only. On the left side, you can see how regular QCall image for S390 looks like of CoreOS. We have 2 partitions labeled boot and root correspondingly. So /boot contains what you usually have under boot, kernel, BLS entries, and root. Root is just root. For secure execution, we added something more. First of all, VDA1, read on the picture, is a special small partition which contains just SD boot or unified kernel image. And this image is encrypted. Green partitions are exactly the same, no difference, but during the build we enable DM Verity option. Who knows what DM Verity is? Okay, so DM Verity actually is a protection which calculates the hashes of partition. It splits it into blocks, calculates hash of each partition, stores it onto a file or to another partition, then it repeats. It calculates hashes of this partition and continues until it has just one hash. It's called root hash, and we append both root hashes for boot and root to our SD boot image. So command line contains both hashes. It's like a Merkle tree. So then we also want to protect ignition. As I said, ignition shouldn't be readable by anyone, and we also want to prevent modification. The easiest way to do it is just to encrypt ignition. So during build of CoreOS image, we also generate a pair of GPG keys. Private key we append to our encrypted SD boot image. So after initramfs, we have GPG private key and then command line. Public key you can fetch on Red Hat OpenShift website. So each build of CoreOS contains its own unique GPG key. So 2 different builds have different keys. But we still have an issue how we boot our SD boot image, because each mainframe has a unique key, and if we don't have all the keys for all mainframes, we cannot run. For that purpose, we have a special key called universal. It's a special key which is only accessible by IBM and a bit by Red Hat. So during a build, we use universal key and sign our image and encrypt it using this key. This key you cannot find, you cannot fetch. Even I don't have access to it. So only built environment uses that key to sign SD boot with universal key, so you can boot it on any mainframe. Sorry, too fast. But we still lack LUKS protection. We still have no encryption for our partitions. So when user has its ignition supports feature called merging. So we enforce LUKS encryption. We wrote a small ignition config which stored in init ramfs. And when system boots, first it checks verity hashes. If they don't match, installation fails. Then we decrypt ignition. If it doesn't work again, installation fails. If everything is okay, all conditions are met, we merge user ignition config with our small, which creates two LUKS partition. We completely erase the file system of VM and create bootfs and rootfs with LUKS encryption and integrity option on. All the keys we append to SD boot image. So image is encrypted, LUKS keys are there, keys are random, so the same build of CoreOS image, if you run it on several times on different mainframes, pristine image, it has different LUKS keys. So on subsequent boot, system automatically decrypts both partitions, checks integrity, and if everything is okay, you have your CoreOS image with secure execution on, and that's it. I managed that we didn't want to change user experience, but unfortunately for security we had to pay a small price. User must provide his own host key. So he has to fetch the keys for his mainframes, or mainframes he's going to use in the cloud, specify them within ignition config with predefined path, and that's it. We take care about re-encryption, about system updates, so every time system updates the kernel, we create new SD boot image, we append again LUKS keys, script up config, and that's it. You have security from the beginning in the cloud. And this is the first solution which is available for public usage. Before I end my presentation, I would like to thank people who helped me a lot during development. It was Red Hat team and IBM team, so without them it won't be possible to make this feature available. So with OpenShift 4.13, secure execution is available, so if you have access to IBM Cloud or you want to try, you can use secure execution and make sure that your config and your VM is protected against hypervisor or other VMs. Here are two links I appended because presentation is not that technical, but if you're interested in technical details, on IBM website there is a big article with a lot of technical details about how secure execution is designed, how SD boot image is generated, because it's not only two host keys. We also generate intermediate keys, symmetric keys, all this stuff. And if you're interested about how secure execution works specifically for CoreOS, on GitHub, an MD file where all the design is written with all explanation about why we use that or why we don't use something. So thank you for watching, and if you have any questions, please ask and I'll try to answer them. Looks like no questions. Yeah. Thank you for watching. Thank you for your time.
So since we are 1 minute left, welcome everybody to the afternoon of the last session for DevConf of this year. And well, almost at your time, so you can go whenever you want.
Okay,
So, yeah.
I can start now. So hi everybody, thanks for coming. I'm going to be talking about the state of continuous integration in the upstream Linux kernel. It's a little bit one-sided from the side of CI and testers, and it's targeted in a big part to people like me, but I would also want to have kernel developers say what they think about it, how they think it reflects the reality, or or doesn't. Do we have any kernel developers here? Maintainers? Oh, hi, great, thanks for coming. Okay, so I'm Nikolai Kondrashov. I work at the CKI project at Red Hat. We are doing continuous integration for the Linux kernel, for internal kernel, and for upstream as well. I'm also working with Linux Foundation's kernel CI project, and I'm developing the KCIDB project within there. I do electronics and embedded as a hobby. So we will go briefly through what's the landscape like for kernel CI, and then I'm going to be defining continuous integration and measuring it, providing metrics I think could describe it for the purpose of this talk, and then we go over what we have and what we cannot have, and what is hard and what we can do with it, or at least what I think we can do with it. So as probably many of you know, there's a whole bunch of different systems that test the Linux kernel, and this is just a small sample. Each of them sends their own report emails and results in their own way, in their own time during the development process. And most of them have some sort of dashboard, and they're all different as well. So kernel CI is the Linux Foundation project that aims to be the kernel CI for the Linux kernel. But so in a big part, they are a CI system themselves, so they check out kernels, build them, test them. They have hardware, and they use hardware provided by third parties, connected to one central system, so they have the dashboard and and their own reports. But also within the project, there is the KCIDB project, which aims to get the results from various other CI systems and put them in a single database and generate reports and notifications and have a dashboard for that, and extract some value from aggregating this data together. The structure of KCIDB is very simple. You just send JSON containing your test results, build results, and etc., and put them into database, show it on the dashboard, and then monitor what's coming in to generate subscription notifications about various results. So we get around 300,000 test reports a day, and looks like 20,000 builds and around 100 revisions per day in KCIDB right now. So the dashboards look like this. It's a Grafana prototype, and we have reports which aggregate the results. If you look real closely, you can see that there is this report was generated from results from 4 different CI systems. So let's define just an abstract way the continuous integration. So it's quite simple. You simply test every change done to the code, or as close as you can, and then give feedback on the result. We'll stop on that. So out of this, you can come up with some metrics. So the coverage, of course, which tells you like how much functionality we're testing, what's the percentage, then latency, how fast we get the results with after testing, after the change was made or presented, and then how reliable the results are, how many false positives or false negatives it generates, and how easy it is to interpret the results that the CI system produces, like how hard it is to figure out what's actually broken. So, and for these metrics, of course, the ideal CI would test everything, provide instant feedback, and we will be always spot on, and it will just tell you what's exactly broken, not requiring you to go in there and read the logs and try to reproduce those problems. And the worst CI would, of course, test nothing or test something else, and will take forever and never produces correct result, and the result it produces basically impossible to comprehend. So the worst CI is much worse than no CI. So with the upstream kernel CI, nobody seems to know, like, since there is no single system and just a bunch of separate systems, and they don't really verify coverage, that nobody seems to know what the coverage is like. So everybody's focused on particular functionality, but nobody, it seems, really measures, code line or function coverage. Of course, that's not very useful, but I mean, like, it doesn't really tell you how much functionality is tested exactly, but it is something that could be measured and could look something like this from you probably saw these reports before. So this is from single run at Red Hat CKI for ARM64 and just typical set of tests. And this includes just some directories, well, most important ones, but not all of them. So this percentages, well, just some percentage. So nobody seems to know exactly what's going on there. Typically, it takes from several hours to multiple weeks to get results for your change or for whatever you merged in a tree. A lot of CI systems still do manual reviews of any complicated results because there are still a lot of false positives, false negatives, and accessibility varies based on the CI system. Some systems provide very clear and very useful reports like sysbot or 0 day. Others, more bare bones. So it's different, but the main thing is that they are all different. So there are, of course, limitations, and first of all, we can only get as much coverage as we have hardware because the kernel is an abstraction layer for hardware, so we need all the hardware to exactly test everything, but we cannot get all the hardware. So that's a hard limit for a CI, as well as for latency, because to go faster you need more hardware to run on. So reliability limit is obviously the hardware reliability as well, but also how well the kernel is working. So if the kernel is buggy and tests failing all the time, like in interesting ways that the creators of those tests don't anticipate, the reliability of the CI system suffers. But that's what CI is supposed to fix. Accessibility is, again, hard limit is hardware availability, because often you get a failure on some hardware that you cannot access yourself, you cannot reproduce it, so it's hard to figure out what's going on. So you have to do read back traces, ask the owner of the hardware what's going on. So it's a difficult process. And of course, the kernel complexity is a limit for accessibility. So tests can only be as simple as the kernel is. Okay, so the coverage, I think, is mostly good. I mean, like, there are many people who want to write tests and who write tests, but because of the other metrics such as reliability, latency, it's difficult to get that coverage out there and to deliver it to developers, and it's kind of sometimes depressing how hard it is. So that's a challenge. So problem with latency is that, of course, not much pre-merge CI is done. And when you do it, you have to be extra careful because there is no authentication for patches that people send to mail lists. Like, anybody can send patches. And you would think 10 times before running that on real hardware in case it blows up, for example. So that's a problem. We can run tests in NVMs, but that's a limited effect. And then, of course, the slow human reviews, the required reviews for the actual test make it longer. Like, if the test completed right after you left work, and then you come in the morning, and then you start going through your mails and checking those results, and it takes a while, so it could delay the results being sent to the developers quite a lot. So the main problem with reliability, I think, is the fact that tests constantly desync from the kernel state, and that's also a problem because the latency is too high. So by the time the test result arrives, the code with the bug is already in the kernel, and it's getting stuck there until we fix it, and then as a result we get more failures with other CI systems, and that's a big problem as well. Another problem is that you have multiple kernel branches, multiple trees, and bugs, jump between them as maintainers pull the changes in, and it's like, hitting at flies with a fly swatter. So, and with accessibility, the only problem I think is the fact that that we have all different reports and we have to, the developers have to try to interpret them all in their own ways, and it takes time. So it's a sort of a network of problems that affect each other. So, and for example, low reliability and accessibility lead to reduced trust towards results from kernel developers. So they're reluctant to look at them, or might say like, don't send them to me if they're unreliable or hard to comprehend. As a result, gating is impossible if they're unreliable, and as well the feedback is less than it could be towards the code and towards the tests themselves. So improvements are slow. So people just don't get their feedback, don't run enough tests, and it's not improving. And again, the reliability and accessibility lead to high latency because of human reviews, etc. And high latency as well is another reason why there is no gating, and the reason why bugs stay in the public code that everybody uses longer and result in more time wasted by everyone. So there's again less time for improvement. You have to review those results and try to understand what's going on, and this leads to even more latency. So I try to summarize how I think this whole system works in this little graph. But we will take a closer look at this later. But if I had to pick one thing, it would be latency. Okay, that's enough bloom. You get your dog tags. I get to drink a little. Okay. So what can we do with this? Well, at least what I think we can do with this. Or rather, what we can't do, first thing that we must remember is that the kernel community is not a single team, moreover, it's not a single company where you can just say like, okay, now we enable gating with whatever we have in fixed tests, and that way we start the whole process and we tighten the feedback loop, and that's just not going to happen because nobody owes anybody much. The companies that run the tests and the developers are kind of have to work with trust, and you have to first fix the test and gain that developer trust before they will start listening and looking at those tests. So I think that's one of the main things in this situation. So what I think we can do is, for coverage, obviously we need more hardware, we need to attract more companies to run tests and to provide their results. And if you have your own CI system, you can you don't want people to control your hardware. You can send your results to KCIDB, and you can also help work on the reporting to make it more efficient. If you would rather contribute hardware and not do your own tests, you can always set up a Lava Lab and connect it to kernel CI. These links lead to instructions how to do that, and in any case you can write to our mail list and ask questions. For latency, I think the most important thing to do would be do pre-merge testing, because again it reduces number of public bugs and has compound effect on many things, on reliability as well. So if you'd like to do pre-merge testing on patchwork or on not patchwork with patches, then you could use patchwork, and that's what some CI systems used before. Pick patches using the patchwork and then test it safely as much as you can, probably in VMs. But while researching this, I noticed that there's about 50 repositories in the maintainers file who are already using GitHub or GitLab instance. And that could be a way to improve the situation by, for example, connecting the GitHub or GitLab CI to your CI system, like like kernel CI is thinking how to do that right now with this new kernel CI API that they're working on. So the idea is that you, for example, publish an action in GitHub Actions that just takes your patch, submits it to kernel CI, and then gives you a check mark after it's done, or a red cross. And why this is better than patchwork is because you get to authenticate the users who submit the merge request. You can say, like, okay, these users get to the real hardware, and the rest of them like needs to be verified before they get access to the kernel CI, and then you actually get your tests running on real hardware. And that could be this effect could be a selling point for other maintainers to get them at least to have a repo on GitHub, on GitLab for testing to get access to real hardware in an easy way, and perhaps do the testing of merge requests and pull requests. So since reliability is a problem, like you should not try to do all the tests at once. It's enough to just start with one test and put it into pre-merge, and talk to the maintainer, decide which ones we need to do, and help start the feedback loop. Well, I have an idea to use KCIDB subscription for that, and the KCIDB subscription system that allows you to pick, for example, like which branch you want reports on, compiler architecture, like particular CI system, anything. So if you're interested in those results, send a message to the mail list, or just talk to me. So then the thing is with latency is that manual reviews are hard and slow, so it's great if you can automate that, and that's what various CI systems have been doing, and that's what we are trying to build in KCIDB. And for example, Graphics CI does this, and you can see the system for entering various parameters of patterns and parameters to match in test results to detect when it's a known issue and it's already a bug open, and so that you do not notify your maintainers about this problem or developers, and keep the CI working. Same thing is done in CKI as well as Red Hat, and Sysbot is doing a similar thing, but they additionally are able to automatically extract identifying information from kernel crashes and then group the crashes into a single group, under a single bug automatically. So that works very well for them, and with this they're able to produce a lot of crashes and reproduce bugs, etc. automatically without human review. So this will be probably controversial. So what I think could be done about reliability is the best way to approach it, apart from fixing the test all the time, etc., is to make sure that the tests are in sync with the code, and what we can do is move at least the most popular, most impactful tests into the kernel repository proper, like LTP, for example, and integrating the kernel documentation, make them official. So that will join, of course, KUnit and K-self-test, but with wider coverage. The problem, of course, is that once you integrate it with a single branch, then it starts, like if you integrate it into master, then it starts testing master, and the older branches will stop working. So you would need to backport whatever you integrated to those branches and fix them. But afterwards, the complexity of the tests decreases, and they become more reliable because they don't have to account for all the different kernel versions and can focus on testing this one, and you can keep them in sync. But that, of course, only works if we actually run those tests and run them fast. So in a CI system, it's important to prioritize execution of in-tree tests, so they're executed earlier and the results produced faster, so that you can shorten the loop and keep them working. Well, accessibility is not so bad, but I think that if we have decent enough uniform reports, it could save people time if they always receive the same report. But there could be different opinions, of course, and often it's the XKCD comics about the various standards that comes up. So it could be just one more report as a result. But doesn't mean we shouldn't try. So come to me and tell me what you would like to see there, and just write us or help the development of the report system. So here's the influence graph again with the improvements I think should go in there, and that's how they could affect the whole system, and in particular developer trust, and the ultimate targets the stronger code feedback and test feedback, which lead to better quality. That's all. Thanks everybody. Any comments, questions, ideas? What do you think? There's somebody behind there?
So just a question, if new patches are submitted upstream, is there any level of requirement or suggestion for maintainers to run CI or run any tests against those new patches, or is that up to every maintainer?
So the question was, when patches are being sent for maintainers to look at, are there any requirements to run tests on those? Is that right?
Yes.
So in some subsystems and some maintainers, they do have requirements and they define the tests that you need to run, but largely I don't think there is anything at large, and that's what Veronica here wanted to work on. Yes, you did, and I think that's what Talis is going to be doing, talking to maintainers and trying to determine which tests could be called canonical for their subsystem, and to put that into, for example, maintainers file, to have it documented, and to have, for example, check patch output the recommendation or requirement for the testing when you generate the patches. Yes? Yeah. Go ahead.
So do you have an idea how many of the tests are possible to run in virtual machines versus the ones that need real hardware? And should there be an effort to make it possible to run more kinds of tests in virtual machines?
Of course, there should. Percentage, I don't have a number. My feeling is that it's a fairly high percentage, especially things like LTP could be run in a virtual machine. I can only say about Red Hat, I think that our test database contains maybe 40% tests that can run in virtual machines. Anybody knows better? It's just my feeling, I'm just poking. I haven't calculated that, but we do have tests which explicitly marked as can run in virtual machine, and that's one way to improve this and to reduce latency and to arrive at the premier CI. Anything better than nothing, anything that will start the loop of fast feedback and get us closer to gating, anything goes. Yes?
Me again. How would CKI work with respect to proprietary hardware? If you're working with a vendor that has hardware that's not yet open or publicly available, could you keep that private and allow it to still run the CKI?
Yeah, we have private tests, and
You have to repeat the question.
oh yes, the question. Thanks, Talis. The question is, how does CKI deal with tests in private hardware? How do we make sure the tests are not visible outside, or the NDAs are not broken? Yeah, we keep tests in a separate repository, the test coded themselves, and I think that most of the tests are still in our KPAD database, but I'm not sure exactly how the very secure, the very secret tests are added there, but we do try to keep them away from the public. Anyone else?
Is there kind of open source project or methodology that you use in order to run only specific tests? Let's say I change only the network driver. I don't have to run the whole CI, right? It will greatly improve the latency. So what's happening now with it?
So at CKI there is a system for picking tests based on patches, and we worked with it for a long time, so we can share that. It's all open source, but we can share the experience and the approach with anyone who's interested. But since we test on real hardware a lot, we have to be careful with that, obviously, and not only to reduce latency, but also to reduce the load, because there's a lot of patches. But yeah, we have a system where we can match, okay, when these files changed and run that test, and things like that. It's quite sophisticated and works quite well. Yes?
Do you see some better engagement of this from the kernel subsystem maintainers, and is there some way in which they can trigger the tests for the things they care about? Like they collect the branch for the next pull request they're going to send to the mainline kernel. Can they easily run the tests on the hardware that affects that?
So there is,
and
yeah.
do they do it?
The question was, and I'm sorry, I'm forgetting to repeat the questions, but the question was, is there a way, like, do we work with maintainers do we provide a way for them to trigger tests for a particular change that, like, they want to do on real hardware? I'm not sure about CKI, but like exactly, like, do they have special branches? But CKI picks up the monitors maintainer trees, and when they push something, it triggers tests, and so do plenty of other CI systems. Plus, there are agreements between maintainers and CI systems that when they ask, like, oh, can you monitor this specific repo where I will be pushing at will to check my things and get a report? So there is that too. So like a special branch that they ask to test, and then get the results after a while. Yes?
If it's possible for an individual developer to trigger the test when he send a patch.
Was the question, is it possible for an individual contributor to request testing of a patch? Not as such, as far as I know. So some CI systems, they do pre-merge testing of patches on a mail list. Like for some subsystems, I think that Intel's graphics CI does that. And some subsystems, but like at least one subsystem has a GitLab repo, and they have CI set up there. So when you open an MR, maybe you will get some tests run. I don't know what kind of access control they have there, but there is no universal agreement how to do that, and there's no single CI system that does this universally.
How do you handle reproducibility? So let's say a CKI test fails and you have to inform the maintainer. How do you go about giving them a workable way to reproduce the issue?
Well, if it's, for maintainers from outside Red Hat, that's a problem. Of course, you just try your best to understand what the problem is and review it, and send an email out manually. That's what our main QE person does from time to time when they notice, basically human review and explanations, because we cannot normally give access to hardware that's inside Red Hat to outside people. For inside developers, of course, it's much easier. They can just get to the hardware, and we provide all the help to tell them how to exactly run that test and reproduce it. So that's a problem, of course. Now that's the accessibility problem I was talking about.
But if you use VMs, it kind of solves this problem. No?
Yeah, of course.
Just run this command line and you get exactly the same.
Of course, and like Sysbot is very good at that. They basically can generate a reproducer for you, like a C program, automatically generated, that you can run and expose a problem in a syscall. Yeah, but VMs in that way are great, but of course CI systems, they do like to control their setup. They have their own provisioning and everything, and to arrive to exactly the same setup that the test was running in is not always easy to communicate to a maintainer. Like for example, CKI, like we have our provisioning and we have our test setup, but thankfully that's not a problem most of the time. So, but still, like it is a bit of a problem to explain exactly, automatically especially, what you need to do exactly to reproduce that. I'm not sure I answered the question.
Because I'm running something similar, but for Windows drivers that run on top of KVM, so I'm just asking questions. We faced in our development, and we actually managed to do some kind of reproducibility. For that, we have to provision the VMs. Because that's how you do the same setup.
Yeah, of course, when you can do VMs, that's much easier. But still, kernel consists of a lot of drivers, and those do need to be tested, and that is a problem. Okay.
Would it make sense to, because a lot of the tests that need to run on real hardware, I assume, is because they need specific hardware.
Yeah.
Would it be better to write the test as a virtual machine test and pass the hardware through, so that it becomes easier to make a virtual user as long as they have that specific piece of hardware that can be passed through to the VM?
So the question was, could it be a good idea? Maybe it's a good idea to at least run the test itself in a stable virtual machine environment and pass through the hardware to the VM, so that at least the test setup and framework and everything could be automated. Yeah, that kind of makes sense. I'm not sure that anybody has tried to do that.
It could be done, but it will not work for any device, the networking device.
Yes, of course, like to kinds of devices, because again, like there has to be support in the VM and everything. But it's an interesting idea, it's worth trying, especially for some kind of devices. Right? Anyone else? Any comments? Yeah?
Yeah, it's maybe more of a comment. Like I do have hardware that I wish I could contribute to that, so that the maintainers would actually run tests on that and catch the bugs before they actually reach the mailing tree. But from what I'm understanding, even if I go there now and try to enroll the hardware in some way, it's not going to happen because people are not actually running any sort of pre-merge test to that, right?
Not pre-merge tests.
This is some world in which this would...
They still catch the stuff that maintainers merge, like for a particular subsystem. And you might get your test executed before it reaches Linux or another maintainer. So
but
that's
if
still
it failed, maybe nobody would look at it. It will depend on someone actually looking at this dashboard result and not merging the patches because they decide not to, because that test failed.
Yeah, that's a bit of a problem. So communication there is difficult. But I think it could still be worth it to talk to kernel CI and to expose your Lava lab there. We talked about it. So you can talk to us on the chat or on the mail list. Just ask what we think about it, and Guillaume probably will give you an extensive answer and ideas for it. All right. Anybody else? Okay, thanks everyone. That's it, I think.
So is it already streaming?
No.
No.
We started streaming
Okay.
on the hour, but we
Alright.
started recording to not have plays.
So there's a difference between stream and recorded.
Yeah,
Got
the
it.
recording is from source. And
Okay.
then streaming is whatever happens on the network.
Ah, yeah. Okay, 1 minute.
Good. We're ready.
Stopwatch. Ready?
Yep.
As soon as I close the door.
I hope you haven't.
Let's begin.
Hello, welcome to our talk about Kernel Development Learning Pipeline program that Joel and I have started at Red Hat, KDLP for short. I'm Julia Denham.
My name is Joel Savitz, and today we will give you an introduction to our program. So, first, a little agenda. So we'll begin by describing what this is, what KDLP is, why we would want to do such a thing. Then we'll give a brief overview of the program, which includes an introduction to Linux kernel development course, some various things related to internships and mentoring, and this new kernel devs program group that's part of some initiatives that we have to get people involved in kernel and grow the kernel groups at Red Hat. Then we'll talk about some of the program growth, some of the exciting things that have been happening, internal and external connections, connection with the Linux Foundation and their mentorship program. Then we'll talk about some of the success stats, a little bit of the numbers, and finally wrap up with some resources so you guys can get involved if you'd like. So first of all, just to make it abundantly clear, what is KDLP? The main idea is that we are trying to build a comprehensive pipeline for Linux kernel talent. It is difficult to get people into the kernel, and so we want to build a pipeline. So, okay, first a little bit of history. Where did this come from? So I went to UMass Lowell, and then about halfway through, I did a co-op with Red Hat. Just completely by chance, I ran into this manager who was hiring at an event he wasn't really supposed to be recruiting at, and I ended up in this co-op. And if it weren't for that, I never would have encountered the Linux kernel. I never would have known where to look to get started. I wouldn't have even really known about it. So anyways, as sort of a side thing, I became involved in an initiative to improve Fedora usability, stability, and performance on the Raspberry Pi platform. And then along the way, so I kind of focused more on the low-level stuff, and there are some gaps between what I had learned in the co-op and then what people generally were familiar with from their computer science education. So long story short, we ended up developing this into a bit of a study group to learn about kernel drivers for the Raspberry Pi. And then that was a part of a directed study, like credit-bearing directed study type of course, sort of independent project that eventually became more of a class-like type of thing with a small group. We ended up making some slides. Through the help of the Red Hat research department, we ended up bringing in some interns to help work on the project and further work on the Raspberry Pi stuff. The course became more developed. We got more interns. Eventually we pitched the program to the Red Hat Enterprise Linux, RHEL's Shark Tank program, and we got the sponsorship of Mike McGrath. Big thanks to him for sending us here. And from there, we continued to develop the program until it became a full-on, credit-bearing course, or a regular course, academic course that we created. It's all the stuff is open source, and we will continue to talk about that later on. But for now, turn it over to Julia to talk a little bit about why we're doing this.
So why did we start this program? So we noticed that many Linux kernel engineers are getting close to the retirement age. I started at Red Hat 3 years ago full-time, and I've already seen a couple retire. We've also noticed that it's really hard to find qualified candidates for for kernel engineering. And most colleges nowadays don't even teach C programming, which is hard to do kernel without C programming. And kernel onboarding also takes a lot longer than the average onboarding time. So our solution to this was to create the qualified candidates for kernel engineering. So there are three main pillars
to the program, the course, the internship, and then full-time work. So students will learn concepts in the course. They'll practice them with weekly assignments that are similar to things that they would be doing full-time at a company. Depending on how the class goes, they could get an internship at Red Hat, interning on kernel, using all the skills they learned in class, helping with the program, and then depending on how that goes, they could be full-time kernel engineer at Red Hat. And Joel is going to go into the specifics of each of the pillars.
Yeah, thank you, Julia. So, first of all, I'll talk a little bit about the Introduction to Linux Kernel Development course. So the general idea with this is to kind of give a meta overview of the kernel, because as you know, it's a gigantic project. There's not a single developer who knows how to rewrite the entire thing. No one is a master of any of the subsystems. So what subsystem do we really focus on? And the answer is pretty much none of them. We go into a couple, but the general idea is to teach people how to teach themselves, right? Teach people how they can get involved in the community, how they can properly interact with the community while using the community standards, which we know about those, right? And so the prerequisites for this course are just a general background knowledge of C, an advanced knowledge of C mainly, and basic Linux experience. I mean, generally programming experience as well is extremely helpful. But the overall idea is to get sort of a tour of the different parts of the kernel, some of the different tools that you can use to interact with the kernel, how to do, how to navigate the code, things like cscope, Elixir, some basic tracing, BPF, specifically the BPF trace implementation front end, and some basic ftrace concepts, right? Which are things that once you're pointed to, they're very useful, but you wouldn't even know really where to look unless you spent a lot of time running around in circles, or you got lucky enough to find a mentor, or just find yourself somehow at Red Hat in a particular department. So everything we do is open source, of course. That's open source for open course. And we've developed a credit-bearing undergraduate and graduate university level course that we teach at University of Massachusetts Lowell in Boston, or in the Boston area. And that we've been running in its current form for 2 semesters now. We just finished the last one back in May. And recently we've been piloting a mentorship program on the Linux Foundation's LFX platform, thanks to partnership with Shuakan, which we'll talk about a little bit later. But the main idea and our main philosophy with this course is that we want to teach difficult material from first principles. So then, the idea is, with internships generally, the idea is to bring people in who have some idea, well, to test them out in an environment where, you're not making a huge commitment to them, right? And they, they're not necessarily, signing on to the whole thing. They're trying something out that they may not know whether they like it, right? So you have an opportunity to kind of vet them and do a 3 to 6 months or longer basically interview, right? And see if they are A, qualified to work in this particular area, and B, that they actually like it, that they actually enjoy it, right? That's something they want to spend their time doing. So with that, what if we went back a step further, right? What if we take, we're working already at the university level, kind of at a semi, training wheels type of internship. And, we're already thinking, like, do they like the kernel? Do they like, are they competent at working on the kernel? Do they enjoy working on it? And from there, we can bring them in and, internships already. I mean, I know a manager who was saying he doesn't even like doing 3-month internships in the kernel, right? Because by the time they have the absolute basics, it's time for them to go. I mean, even 6 months is not very long. I extended mine to 8 months, and I still barely knew what I was doing at the end of it. So the idea is, if we can get people set up with some of the tools, the ecosystem, right? Some of the the Git email patches. I didn't mention that earlier, but that's a very big important component of our course. Getting extremely familiar with Git and email patches, right? Because if you can do that, that's a big part of the hurdle into getting involved in the community. But if you can do those things, if you have this competency, then when you get to your internship, you can actually hit the ground running and accomplish a lot more in 3 to 6 months than you otherwise would, right? And so by the time that we actually recruit them to full-time, ideally, they can hopefully shorten that 2-year onboarding window that Julia mentioned to a lot shorter, and then saving everyone involved time and money, which is great. So at the same time, we want to support the key initiatives within Red Hat, right, and target people towards areas that, that are growth areas, and train new talent, right, while focusing on areas that people otherwise wouldn't really be exposed to. So, and now I'll hand it over to Julia to talk about some of the initiatives that we're doing within Red Hat to bring people involved and bring new people and interns, together to learn more about the kernel.
So one aspect of the program is this group called the New Kernel Devs Group. It's a way to kind of connect all the different pillars of the program. It's an internal group at Red Hat where kernel engineers of any level can come. So we have a chat, so you can always send messages in chat or on the email list, or you can come to our reoccurring monthly meeting and ask questions, give presentations. Like if you're new and you want to practice giving a presentation, it's the perfect space to do it. Or if you're nervous about asking a question, you can come and ask in this group. So program growth. Throughout starting this program, we have partnered with different organizations within Red Hat, including Red Hat Academy. They've sponsored us to go to a few conferences. They've helped us out learn how to work with colleges, and we've also met with their curriculum team to potentially get our curriculum up on their platform, but that will take a lot of time. But they were very interested in it, which is awesome. We've also worked with the intern program in Waterford, Ireland, worked with Julia Blay. We ran a workshop, a kernel engineering workshop, once every 2 weeks for, I think, 4 months for a group in Ireland. It was virtual. And one of the interns in that workshop actually just accepted a full-time offer, which we're super excited about. We've also been working with a few other intern programs at Red Hat, and we're hoping that we'll partner maybe with Brno or Israel in the future. And then our newest program integration is with the Linux Foundation that Joel will talk about right now.
Thank you, Julia. Yes, so to build on that point about the Linux Foundation, so last year at LPC, we were talking to different people about the program. I ended up talking to Greg Cole-Hartman, telling him about what we're doing. And he was saying, "Oh, we already have something like that. We have the kernel bug fixing thing." He said, "You should talk to Shua Khan." So I was introduced to her, and we started talking about her mentorship platform, kind of comparing some of what we're doing and what she's doing. And we found that by working together and by offering our course on their platform, we could provide some complementary content and strengthen the value of the service that we're providing while also adding something to the Linux Foundation. So she was very helpful in working with us on this. And so we've piloted having a Linux Foundation mentorship group cohort in our course this past semester. And we learned a lot from that, but it was a very good pilot program. And at the same time, we got UMass Lowell students involved with the Linux Foundation's mentorship platform and got them kind of a nice, get their names on there for being involved in Linux, right? It's a nice thing that they can have. They can show hiring managers, put it on their resume, right? It also actually unlocks, some Linux Foundation programs that are only open to graduated mentees. So that's very cool. It also allowed us to have probably the most diverse group of mentees or, students, different terms, right? That we've ever had, or that we could have possibly had if we were only working in Boston. We had people from all continents, pretty much. Well, not Antarctica, right? But we had people in a few African countries. I think Nigeria and I don't know. There's another one. Some people in Central and Eastern Europe. I think we had 3 or 4 in India who were interested. A couple in New York and Texas. There's one guy in Peru. Really all over the world, which was very cool. So next, I'll talk a little bit about some of the numbers, some of the technicals here, right? So this 3, right? It actually was 2 until like a week ago, right? We've had 3 full-time hires come through the program in various forms, and through our efforts, we were able to get them interested in kernel, teach them a little bit about kernel, and then place them within various kernel groups, right? So we have some relatively new talent there, which is exciting. There were 2 people who did co-ops with us that really liked Red Hat, but it was a difficult time for Red Hat hiring, and they were both recruited to Amazon and Microsoft because they were good at what they were doing. One of them, and this is an interesting thing about our program, he liked working at Red Hat so much, and he liked the environment, he decided the Amazon juice really wasn't worth the squeeze, and he wants to come back. You know, he really liked the Red Hat environment, and yeah, so he actually left Amazon recently, fun fact. But overall, we've had 7 interns and co-ops who have been vetted and trained by our program and then come through and do internships with our group in various forms. Some of them less connected, working with other teams. Some of them working a little more closely with us, working on the program. And overall, it's approximately 30 students and mentees completed Introduction to Linux kernel development during the past academic year, which we're happy to announce is the most diverse group ever by gender and location.
So a little bit of program information. So who runs this? It's Joel and I. We have Charlie, who started out as a student, then he was an intern, and now he's full-time. And he is our course content lead. And then we have Dennis, who has interned with us. Well, he took the class, then he interned for a year. He unfortunately has to go back to college, but we're hoping he will come back to Red Hat when he graduates. One thing is this program is not part of our full-time job. We do a lot of this work on the side, and we work closely with our executive sponsor, who we'd like to thank, which is Mike McGrath. And we'd also like to thank Heidi Dempsey, who's been helping us out a lot with dealing with the interns. And here are a few resources to leave everyone with. We have a mailing list that we send a quarterly update newsletter to. So if you just want to be informed about the program, that is something that you can join.
Low traffic.
Or if you have a specific question, you can reach out to Joel or I. And then we have a website, and that has all the course information. And like we said, it's all open source. So if you're just interested in looking through some kernel slides, that is the perfect place to do it. Yeah, so any questions?
How do you feel people would react about shifting things around to make the kernel introduction more closer to what people usually see after they left it? After they start working in computing today nowadays, like start making your first contributions using like GitLab, GitHub, full CI, maybe with help from CKI or something like it, and then you lead them towards the actual kernel workflow. Like now that you know how kernel works and you send your first patch through GitHub, try to send a patch through the main list and all that mess. And so, how do you feel people would react to that?
So our philosophy with the Git email patch stuff that we do is that, well, it's very tricky to learn, right? It's very finicky. And so the first few assignments are, we provide a couple of chances where the real challenge is just doing the email patches, really. Like you send some email patches, you get it going. And the idea is, it's a stripped down version of Git where you really understand the fundamentals of like what Git is, right? Because there's a lot of extra abstraction that's added on GitLab, that's added on GitHub. And those are very useful tools, right? But they kind of build on this abstraction that, Git was originally created by Linus Torvalds to work with his other project, the Linux kernel, right? And so by making people do it many, many times, they get really good at it and they get a really solid understanding and a firm foundation about what Git itself is that would allow them to go to GitHub, to go to GitLab, and then in their minds have a more clear separation of the abstraction of GitLab and pull requests. Like, what is a pull request? Well, on the mailing list, it's someone sends an email requesting a maintainer to pull from their branch, right? It was a little confusing, I remember, when I started out to say, like, well, pull request, like, how does that relate? But I think by learning, the original workflow and really hammering it in so they really have it well trained in their mind, they get a good understanding of Git, they get a solid foundation for working with the kernel, and then they're able to better understand the other abstractions, and I think work with them even better.
the introduction to the sub-maintainer or maintainer or that sort of thing work? Is it explicit? Do you connect someone with the sub-maintainer as a part of the kernel, or do you, describe how to present yourself, how to interact, how to submit your patch, how to have that conversation, or how does that part work?
Well, we probably could get more sub-maintainers involved. That's an interesting idea. But what we have them do is, so they're not, they're submitting email patches against a base repository that's like our assignments repository. There is a point where they do generate patches right now. I mean, we're making some changes, but they generate patches against the kernel, and they include that patch as a part of another patch, which is like a little confusing for them. And then they send it to mailing lists where other students have, as a part of their their grade, they review each other's patches and they get feedback from each other. It would be interesting to integrate more of the sub-maintainer kind of workflow, but I think that's an interesting point. That's not something that we've integrated yet, but it's a good idea.
Have you guys tried to partnership with a Digital Challenge?
Yeah, it's yeah.
Repeat it.
Repeat the question. Oh yes. So we partnered with EduLipta Challenge, I think is what it's called. Is the question, and the answer is it's been shut down. They're not letting other people in. Apparently, it's a bunch of bash scripts that people don't want to maintain anymore. And I mean, we probably, I'll talk to Greg at some point if I see him. Maybe I'll mention it, but I think they want to move on from that at this point, unfortunately, because it was sort of, yeah.
I remember Greg mentioned sometime they actually were trying to come up with a new model.
Oh, really?
So it's not like they decided to shut down indefinitely, but maybe it's simply because they were just a couple of people writing a bunch of bash scripts or replying a lot of people getting involved in it. So there were not much help on their side, I think. That's why they shut down the project.
Yeah, so the response is, that maybe there's a new model going on. Yeah, I mean, we've discussed this with Shua Khan a little bit, and she was saying like they're very protective also about the code, because they use it to, the source, because they use it to evaluate people, and they really don't want this stuff getting out there. Some of the evaluation stuff, you have people all around the world trying to break this stuff and show that they can, I mean, unfortunately, kind of falsify that they've actually completed some of these challenges, but. It's interesting. I mean, it's definitely a interesting model. Funny story. Someone actually mentioned, they came up to me after I did this talk at FOSDEM, right? And they're like, hey, do you remember EduLipta Challenge? I was like, oh, when was that from? Like what? And it was like, oh, like back in like 2015, 14. It's like, well, yeah, I was in high school. Like I didn't know what was going on with Linux at the time. So it's a bit before my time, and but it would be interesting to try and work with Greg if he's interested in that, but. I don't know. From what we heard from Shua, it's no longer operative.
If there's no other questions, thank you for attending our presentation.
That's the best version I've seen you do.
should I start?
Whenever, but you're a bit before time. If you want.
Hi everyone. So this talk is called Secure Python Development, Tips, Tricks, and Tools. I'm Dominic de Librere. I'm a software engineer at Red Hat. I thought I had Red Hat under software engineer, but I think that disappeared somewhere. I work mostly yeah. I work mostly on internal tools and internal processes within Red Hat. So what I'm going to present to you is not a project. It's not really even anything new exactly. What it is a summary of things that you can get started with if you want to bring some secure development practices into your Python projects. This is just a summary of what I've discovered as part of a team working on trying to make our coding more secure, and particularly in an environment that uses a lot of Python and uses a lot of CI/CD. So I'd like to lay a few ground rules. The first is that I'm not the security police. I'm not the Python security police. I can't tell you what to do. I'm not your mom. So anything I say here is advice from my experience. It's not the law. Security can only be improved, not perfected. You've probably heard it before if you've read anything about security. But it bears repeating that anything here is not going to make your coding perfectly secure. It's only going to maybe help you get to that next step of a more secure environment. Also, I'm going to mention a number of tools here. You'll see logos for different projects that you can use. They're not really endorsements. These are only the tools that happen to be familiar to me, and they're here as examples. So I'm not recommending one thing over another necessarily. We're going to focus on a few different areas for secure Python development. So first I want to focus on secure dependency management, basically how to know that you're pulling in the right Python packages and formalize that process. Secrets management, because like any software project, a Python project can have a dependency on credentials, API keys, etc. And Python has particular ways that you can manage those safely. Static application security testing, or SAST. Again, this is not unique to Python, but Python has a unique way of interacting with SAST. Some basic network security reminders around Python, and how to enforce best practices in Python coding so that you have a common starting point for a secure development in your Python project. So here's the Python package index. I think, well, I don't want to speak for everyone, but I like the Python package index. I like being able to pip install things. It's very nice. But there are some security challenges around that model of installing software and adding dependencies to your project. So the challenges we have are isolating Python packages from the system-wide Python, making sure that the library versions match across different environments. This is a challenge for everything, but obviously one Python environment could have different library versions from another, so that's another challenge. Vetting package releases before trusting them in your application, just as you would in any other language that has its own package management system. But we have particular tools for that in Python. And verifying download integrity, just the basic making sure that you are downloading in a verified package, mitigating against so-called man-in-the-middle attacks, etc. So in terms of isolating packages from the system-wide Python, The very basics that you likely have heard already are like, please don't use sudo pip install on your main system. So instead, you want to be using a virtual env. You've probably heard that. They've been around for a while, but it bears repeating. But it also helps to use tox to provide dependencies. Tox is a great system for running all your unit tests in one place and in a predictable way. But it can also provide kind of a front end to various other things that you might be doing with your Python application or Python scripts. It provides a very reproducible way to install dependencies right when they're needed into a temporary environment and tear them down when you're done. So that's good for lint checks and unit tests, but again, lots of other stuff you can run with tox. You may also want to consider something more comprehensive than tox. There are whole Python packaging systems that will integrate that kind of dependency management. So those include Hatch and Poetry. Those have both been recommended to me. And we definitely want to make sure that library versions are matching across different environments. Tox, for example, takes requirements.txt often. A requirements.txt doesn't have to have versions in it. You could just be writing the names of packages, and that could result in inconsistencies. One thing to help with making sure that you have the same version everywhere across different development environments is pip tools. Pip tools is a project that has basically two main utilities in it, pip compile and pip sync. Pip compile converts a requirements.in file to a requirements.txt file. So in a requirements.in file, you can be a little bit vague. You can say, I want requests, but you don't have to say what version of requests that you want. If you're okay with it having a strategy of pulling in, say, the latest available version or the current default. And a really nifty thing about that pip compile is that you can pass a generate hashes flag to it, and it will compute checksums SHA-256. So a nice secure hash that you can use to validate those requirements when you're pulling them in. So later, when you run pip and install all of those, it's actually checking hashes as it downloads the packages. The annotate flag is also very useful if you've got this in a shared project and you want to see where a dependency came from, because you install requests and then it pulls in something else. There are certainly packages with much deeper dependency chains. So annotate will show you how you ended up with that dependency in your project in the first place. Pipsync is the other command that's in the piptools project, and that will update your virtual env to help you keep those packages fresh. So this is a smaller solution than one of those full packaging solutions that I mentioned earlier, like Hatch or Poetry, but it helps you manage the dependencies in a similar way. Of course, as with any language with a package manager, you want to be vetting the package releases that you are using them before you trust them. It's really simple, but again, just asking the basic questions. What other projects are using this package? Who maintains it? Do they respond to bug reports? How active is this project? And you can be checking change logs to see what's coming into the project, what new features are in there. To help you with checking those dependencies that you have, there are dependency scanners. So the example I chose for this presentation is called Safety. Safety will scan your project for dependencies that have known vulnerabilities and tell you how to remediate it. So if that means that there's an upgrade without that vulnerability, it can recommend that, or even if there's like a small downgrade that reverts that vulnerability. It can recommend that as well. You can integrate it into a CI/CD pipeline. The thing is, this is an open source project, but it's on a model where for non-commercial use, you can use their free database. It's very good, but for any kind of commercial use, their license asks that you, or requires rather, that you buy an API key from the developer behind safety, which is PyUp. Verifying download integrity is pretty easy once you've got a tool like those package managers I mentioned earlier, or pip tools. So there are specific suggestions that the pip team has for verifying download integrity. The first is that you use pip instead of running a setup.py. Setup.py is arbitrary code that you're invoking. I mean, you could read it first, obviously, but it's considered safer to use pip these days because it does more than just running the setup.py. There are certain checks involved. You can pass a require hashes flag to pip, and that will verify the downloads using those hashes that you added in with the pip tools. And you can use the only binary flag that's recommended. So if you run the only binary flag, it will pull in binary packages instead of pulling in the source package, which means that it will simply place the files where they need to be instead of running setup.py, etc. So this is kind of like an extreme case. This is a lot more work, but if you have an environment where you really need to place a barrier between yourself and PyPI, there's the option of caching PyPI. You can have your own mirror of PyPI. You can vet everything that comes into it, all the updates, and you can choose what you approve and what you don't approve. This is just one example of like an enterprise solution that one company has proposed. They call it Nexus Repository. I just provided that as an example, but I should also mention, you may have seen the table for a project called Pulp lying around. So that's another example of like an open source project that's out there trying to provide various ways of mirroring different kinds of repositories, not just PyPI, but other sorts of repositories as well. Now, like anything, a Python application might need passwords, keys, certificates, tokens. These are all secrets. They're things you keep secret. The obvious thing that you probably have had drilled into your head for years is don't hard code secrets into your Python source code. But also don't store them in secrets. Don't store your secrets in source code management. There are private source code repos, obviously, but really no source code repo was ever meant to hold secrets. They're meant to share things, not to keep things secret. So if you really have to store secrets in SCM, because I'm not the security police and I can't tell you not to do it, then at least use Gitcrypt so that all the secrets are PGP encrypted. Gitcrypt is a transparent process that it's a plugin for Git. So once you integrate it with GNU-PG, it will use your private public key pair to just transparently encrypt any secrets that you're adding into the project. It's a little more complicated than that on a project with multiple developers. You have probably multiple keys from your team, but it will handle the math essentially of using all of those keys to encrypt the secrets so that any one of your developers can then go back in and decrypt them. But that will probably make revocation harder if you ever have to do that. So rooting out plain text secrets in source code management also has some tools. So some examples are projects called Detect Secrets and Get Leaks. You run these either locally or in a CI/CD pipeline, and they scan your project and say, hey, this looks like an API key or a password. Often it's scanning against lists of known credential formats, or it might do a little bit of entropy detection, but either way, the idea is to point out these might be secrets, and you can either mark that as a false positive, or you can take it out of your source code and obviously revoke that secret. You don't want it live anymore. So anytime it's possible, instead of using a source code management for your secrets, you want to use like an actual secrets management system if you're sharing that with a whole developer team. HashiCorp Vault is the big commercial example out there. I mentioned it here because it happens to have good programmatic access to secrets. And the way you can do that in Python is with HVAC, the Python client for HashiCorp Vault. That's a community-supported client, so it's not an official part of the supported HashiCorp Vault system, but it's good and it's out there. But moving on from secrets, we have security linting. There's a good chance you're already linting your code for style, but a security linter does something similar where it builds an abstract syntax tree from your code. A style linter will usually throw up an error if it notices that your code isn't syntactically valid, and then move on to style checks. Security linting, instead of going into style checks, will go into security checks that will look for common security issues. A good option for security linting is Bandit. That's open source. Again, run it locally, run it in CI/CD, but it just looks for common security issues in your Python code, including things like, for example, you've run a shell command with a subprocess or whatever like standard library function you've got in Python for running shell commands, and you've just thrown a variable in there. This will throw out an error, and you have to decide if it really is a security vulnerability in the context of your project. So for example, you can mark this as a false positive if what you're developing is a tool that developers run on the command line in their own environment, and they're allowed to give input that is going to go right into a shell command. They're just doing it on their own system. That's not really compromising security. Or, for example, you're already thoroughly sanitizing variables that you're putting into your shell command. You can say, well, it's not a vulnerability here because we've thoroughly sanitized these variables. But maybe it is a vulnerability. Maybe you're taking user input from a web application and putting it into a shell command, and then you'll want to fix that instead. So static application security testing can kind of pull all of these things together. There was a great talk earlier in the conference about effective SAST, so I won't repeat all of that here. But the examples that were given there used mainly semgrep, which is nice. It's an open source SAST tool. The example I decided to provide here is SonarQube. So this is kind of an open core type thing that you can use for SAST. There is a community supported open source version of it, and then there's an enterprise version that they sell. It does do all those dependency checks that I talked about that you can do with something like safety, but it also performs the security linting, and it provides you with what are called code smells. So if you're not too familiar with SAST, a code smell is essentially something that is maybe just not best practice, not necessarily a security vulnerability, but something that makes your code maybe more prone to errors in the long run. So for example, the first time I started using SonarQube, I got some code smells about strings that I was repeating, string literals that repeated a few times in the same piece of code, and it said, hey, this could be a constant, which I hadn't thought of, and I just went and corrected that. Easy to do. It will also pull in your unit test coverage metrics. So if you're running PyTest, maybe you're running PyTest through Tox, or you're running some other system that runs all of your unit tests, it can take the output metrics and parse them. And a wonderful thing about it is if you're integrating this into CI/CD, then it's going to be able to focus on just the code that's changed in a merge request or pull request, and tell you what percentage of that new code is covered, or how many code smells are in that new code. So for gating, that's very good, because you don't have to filter out a bunch of false positives off the bat. You can just focus on improving the code that you're checking in now. So you can start adding better formatted, more secure code now, and gradually improve the security and formatting of your overall code base. And you can set up, I think I said you can set up gating, but anyway, that's basically just, you've got a percentage, right? I need this percentage of coverage, or I need a certain, it needs to be under a certain threshold of code smells in the new code, etc. But this is, again, just one example. I like it for this presentation because it does integrate with like PyTest coverage and things like that. It will tell you how those metrics apply to your code, your pull request. So basic network security reminders. Again, nothing new. Please use TLS. So anytime you're interacting with APIs, you really want to be using HTTPS rather than HTTP as your prefix. You want to be using that certification, and this is like a super niche issue, but as just kind of an example of the way this can go wrong. Say you're in an organization that has like a self-signed certificate for things on an internal network. Requests has this weird quirk where it doesn't use your system CA bundle to verify TLS. So you might have a custom certificate authority installed to check these things, and requests just won't use it. So, so the temptation in this example is to do something like just turning off SSL or whatever for certain operations. But instead, you can just use an environment variable to point to your CA bundle. So this is an example where, unfortunately, the secure thing to do isn't the easiest thing to do. It's kind of a weird edge case, but I like this example because it points to an area where you would ideally like to make the secure thing to do just the easiest thing to do, the path of least resistance. Anyway, you also want to check for precise correct URLs. We live in an age of like typo squatting. You've got two letters switched up, and then you end up at the wrong URL that is controlled by some attacker. You want to specify the fully qualified domain name if you're doing container image pulls. This is not directly related to Python, but a lot of us are going to be working with containers connected to our Python projects, and there was an old way of doing things where people didn't specify like docker.io/name of container, and that's not good because nowadays there could be multiple registries. The order that registries are queried in could be different, and that is a similar problem to typo squatting. And obviously, you want to rely on standard network cryptography and authentication libraries. You don't want to be making your own solutions for these things because there are tested solutions, and if that's not the focus of your project, then there's really no sense in creating something that's less tested. Now, I want to talk about enforcing best practices on a team project. You want to set expectations for code quality, and some of these things might not seem security related. The issue is that code that is following certain best practices and that is consistent across a team is going to be code that's easier to review. And good reviews of code lead to more secure code in the long run. So you want to be running unit tests on all merge requests, all pull requests. You want to have unit tests to begin with. I think I bring that up again later, but it's always good to repeat. You want to create code coverage or SAST code quality rating thresholds. That's the gating that I was talking about earlier. There's a number of ways to do that. SAST makes it pretty easy. You want to be using code formatters maybe. Not everyone likes code formatters, but they can help if you want that consistent code style across a whole team for, again, easier code reviews. So if you're going to do something like that, I recommend Black. They call it an opinionated Python formatter. You may have seen it around. Not everyone likes it because it has very specific ideas of how your code should look, but it also takes all the work out of formatting. It just formats. Linters like Flake 8 are also good. So maybe you're okay with having a looser format, but you want to avoid anything that like the Python peps tell you not to do. For example, Flake 8 is good for that. And this is really what I said at the beginning of this section, but code style can be something of a security issue just because it's easier to be on the same page when you have a consistent style. But back to like these super basic things that you've probably heard a million times already. Use Python 3. If you've got legacy Python 2 code, I know what it's like to have legacy code lying around. There's ways to make it a little bit easier. There's libraries like 6 that you may have used years ago, and maybe you want to pick them up again. They're good for bridging that gap as you're moving from Python 2 to Python 3. Obviously, the reason for that is just that Python 3 gets security updates, and Python 2 doesn't get updates anymore. You want to have unit tests, definitely. So many things that you could catch with them that you might not otherwise notice. And it can be incremental. You can have like, you can go from no code tests to like, I don't know, 10% coverage, and that's better than putting it off until you can reach 80%, right? So if you want to start with just requiring a certain amount of code coverage for new code that's coming in, that's often a great approach that lets you build up coverage over time. And you want it to be meaningful coverage. You want your test to actually make some kind of sense. But you know, if your test is just running a function, then at least you're catching something catastrophically wrong that prevents your function from running, right? So some coverage is better than no coverage. Sorry, go ahead.
About requiring coverage for new code, do you have an example of a way to do that technically, or is it just like manual gating on merge requests?
Yeah, so the SAST tools that I talked about can apply code coverage metrics to just what's included in a pull request or merge request. So it's not too manual. It's like actually fairly automatic. You can even, you know, I'm most experienced with GitLab CI. And if you're integrating those kinds of tools into GitLab CI, you can actually say, you know, throw up a badge on something if it doesn't reach that code coverage threshold, on just the new code. So like if the new code is beyond 80% covered, then it gets a green badge. If it's like under, then it gets a red badge. And the code reviewer says, hey, it's not ready yet. so that can be super helpful. It doesn't have to be manual. It can be easier if you have the right automation in place. Thank you, that was a good question. Using established libraries for cryptography is super important. I think I already said it, but like, again, don't roll your own crypto, as they say, but also don't make your own SQL requests. These are maybe obvious things, but like, maybe you're coding fast and you start to get into these habits of reinventing the wheel. So don't. There's great libraries for handling SQL. If you're doing SQL and HTTP requests and stuff, you probably want to have like a good framework. You probably want to have, you know, whether it's something as big as Django or something lighter, maybe you just need Flask or something. But you probably don't want to go into this territory where people have already done the work of doing these things securely and just kind of like forge ahead. Instead, you've got community-supported projects to lean on. So I'm gonna end now. If anyone has any questions, I'd love to hear them. Hey.
Yeah, I'm curious about the tool that you spent at the beginning, the big tools, would generate you a file with all fixed versions. In some cases, you might be interested in getting always the latest. For example, I don't know, networking libraries. So how do you reconcile those two things? Do you have some periodic bumping of your libraries, or?
Yeah, I think that's mainly what pipsync is for. Is you can run that periodically, and it can help you upgrade things. You can it's been a while since I tinkered with pipsync, but like pipcompile itself also, you can run it again. You can it will regenerate things, and there's different settings you can run. So you could basically wipe out your requirements.txt and rerun pipcompile on the requirements.in, but you don't have to do it that drastically. You can do just like, I don't remember all the options, but you can do just portions of your dependencies that you pull in the newer versions. I think you can target like, oh, I want to upgrade this dependency and run pipcompile that way, and just say like, upgrade that one, the rest of them are fine. So there's like some customizability there. Yes, please.
You mentioned poetry.
Yeah.
As we're at this particular conference, are you aware of a way to make poetry install just the project you're in, like the one you downloaded and want to work with for say, using in a spec file?
I have to be totally honest. I have like very much no experience with like these comprehensive systems like Poetry or Hatch.
Yeah.
They were recommended to me, but personally, I've been using the approach of using all these other like individual tools to focus on the individual problems instead of like the all-encompassing thing.
I suspect this could actually be a topic for a whole talk, so just wondered if you...
Yeah, I'm sorry I don't have the answer, but if you give a talk like that, I will attend it.
Yeah, I'm not going to do that in a long time.
Any other questions?
You mentioned a SAS tool like SonarQube, and you also mentioned Bandit. So Bandit will be something that runs inside these SAS tools.
Yeah, I'm not super sure about the like provenance of the security linting within SonarQube, for example. Like, I think there might be some in-house stuff going on there, but you know, if you're not running something like SonarQube that's already going to do security linting for you, you can run Bandit as a standalone thing. Any other questions? Okay. Thank you all for coming, especially those of you who are here live in the room in the middle of a Sunday. Thank you.
And we're almost on time. Thanks for joining me for this last session of this year's DevConf. Or well, penultimate session, I should say, because there is a win-win-win session today with amazing prizes, I hear, and amazing quizzes. So thank you for bearing with me. I'll try not to make this too long because I know you've had an amazing conference and all your heads are filled with these amazing ideas and the new information that you got. But the thing that I want to talk to you about sort of ties into the overall theme of this conference, and that is that nobody knows that your service is open source. So this doesn't work. Let's use that. What is the talk all about? First of all, let's start with the challenge of services to open source. Then let's continue to understanding what does it mean to be an open service. What are the basic requirements for any given service to be considered open source? And then let's actually decompose that a little and look into, an actual tangible list of things that you can check, and that you can check against to verify that your service is open. Then let's go into one example. Let's look at Image Builder and see how open Image Builder is. And finally, let's figure out how you can let everyone know that your service is open source, which sort of, concludes the talk with a demo, and then finally a quick poll for a logo for all of this. So, the challenge of services, go watch the keynote. This is something that we've talked about at the keynote of this conference. I can say a few words about it, but I don't want to talk about it at length because it would really mean repeating the keynote. So, open source is facing a challenge. Services and managed service offerings do not necessarily have the same implications that other open source services have for our way of consuming the software. We're not really copying it onto our drives, for our way of inspecting the code, because if the code is not here, how can we make sure that we can actually look inside? And also for changing it, and then for contributing it back. So our entire flow basically is questionable all of a sudden. And the question is, how can we fix this? How can we improve things? And that is a very general and big question that I can't answer here and right now, but there are already services, and that was also part of the keynote, that are open source. And it's just not really discoverable about how we can use our sort of the workflow that we know from contributing to open source and from inspecting the code. How can we apply that to services? And that's something that I want to look at today with you. So first of all, let's start with the first bit. What is an open source service? Steph already mentioned this at the keynote. We have two very basic requirements that we've defined. All the code and assets have to be open, and the public should be able to contribute. I mean, these basic requirements apply to all open source software, I would say. Like, generally, that's what it means. You're able to look at the code and to look at everything that makes up the software, and that you're able to contribute. And the same applies to services, but as I said, it's in a slightly different way, because you don't necessarily download the copy of the service locally and run it, so you're not able to necessarily inspect it or to contribute back. So let's decompose that a little bit. Let's look into what could this mean. Like, what could these two requirements mean? Because just looking at the two of them makes you think, wow, this is a bit incomplete, or at least it's very general, like, sure, the source code could be somewhere, and it could be accessible, but it's possible that you don't really know about it, or that the contributor workflow isn't even described, because nobody ever thought that anybody outside the team that is actually building the service, is running the service, would ever have any interest in contributing. So, how open is a service? The first two requirements sound really familiar, You want to have open assets, and you want to have an open contribution workflow. But at the same time, this implies many things around those two requirements that also need to be met. So I will go through all of these in more detail now, but just roughly, if you have a contribution workflow that heavily relies on documentation being available, you need to be able to follow instructions, you need to learn about the service to be able to contribute back. You need to be able to submit tickets or read existing tickets in order to be able to understand, you know, which issues have been discovered before, what has been figured out before. You need to have a way to communicate maybe with the authors and maintainers of a service. So open communication is definitely key. And then finally, and that's a bit of a stretch goal, of course, open operations. So open SREing of a service. So making that as open as possible. Actually, Michael, who also had a talk today on incident management, he came up with this open source service scorecard system that I based these 6 points on. I think they make a lot of sense. They may not be complete, but I think they give you a very good starting point for understanding how open a service actually is. So let's look into what open assets means, because, you know, it sounds very obvious in a way, but what does that all entail, and which parts of a services code are necessary? Because there you will discover the differences between traditional software and services already. So the first one is obvious, the source code is open, and the second one, unit tests are open. That's also sort of something that we're familiar with. You know, like we have unit tests in our software in general. We might even have performance tests and functional tests, but these become more and more important when software is long living and running as a service. Then you need to have these types of tests. Necessary, of course, is also that all the dependencies are open source, because otherwise, how would you be able to understand how systems tie into each other and how many dependencies make up the end product, you know, the final service that you're consuming? And then the sixth point is, you know, where it really differentiates. You want to have the metadata on how the deployment works. I mean, this is why it says metadata and not just deployment. The deployment is open. You will have secrets in your deployment instructions. You know, you might have a YAML file lying around somewhere that's called deployment YAML, and it describes how your service is being run, I don't know, on OpenShift or on any type of cluster. And you, of course, don't want to expose your secrets, but you want to expose the template. You want to give people an idea of, you know, how is this service actually being run. And there is really nothing bad about that. I would say there is very little risk involved with telling people how the service is stood up. Then the contribution workflow. The first point is very obvious probably, that external contributors can follow the same workflow as team members. It sounds very obvious, and it's something, you know, from traditionally working on open source software we used to. You know, we download the source, as I said, and, you know, we fiddle with the files, and maybe the team was very nice and included some editor config or other sort of instructions that your IDE is set up in the correct way, that your contributions will go in smoothly. But overall, sort of traditional software is meant for local execution, while services are not. So you need to have a way of actually following the same workflow as a team member. That means, that could mean developing against the staging instance that is publicly available. It could also mean locally bringing up the stack in some way, be it through, I don't know, Docker, or actually running a deployment locally if that's feasible of the service. Then, of course, the second one is also very obvious. This workflow needs to be documented. It sort of ties in with the documentation requirements. I'm not repeating it there. But this workflow has to be very accessible and readily available. The third one is sort of, again, opening up the workflow to everyone. Contributors that regularly contribute to a service should be able to run CI. Why is this? I mean, why do we even have to mention this? This is, you know, whenever we submit a pull request, CI runs, and that's it. But running CI on services can be expensive. You know, it depends on which kind of testing you're running. Sometimes you're bringing up an entire cluster, you're trying things out. Maybe there are other services that depend on your service. And this can be a very expensive operation, so you might not want to expose this fully to everyone at all times. That's why it says regular contributors, so that you sort of, you get the mental model of people who regularly contribute to your project get a way of doing this, be it through, you know, a team member approving it, or having a separate group, you know, in role-based access control, where regular contributors can get in, and then their PRs will automatically trigger CI. And then the fourth one is really more of a social thing, I would say. I mean, you can codify it, you can make a rule in your team, or you can really make it very clear, but external contributions shouldn't be stale, you know, they shouldn't go unheard. And this is something that, I mean, the more contributions you get, you know, the more challenging this becomes in any type of open source project. That external contributions are basically the future lifeline of any project. If you don't review them at some point, you know, this flow of contributions and this interest might dry up, and the project might die out. And the same is true for services. So this is very important in terms of having an open contribution workflow. Issue tracking and planning, that's very straightforward, I guess. You know, having an open issue tracker and exposing all the issues to the public, and having an open roadmap. I guess the level of detail that you include there, or sort of what that roadmap entails, that may differ, but overall giving the public a way of understanding which direction your project is heading, or which direction your service is heading, which things you intend to implement next. Documentation is also fairly straightforward. You want to have user documentation and developer documentation, but in this case, you know, the developer documentation needs to include things like operational instructions. So it needs to be clear what the people that actually build the service expect around the maintenance and the running of that service. Well, communication, sure, you know, you need a public mailing list of sorts, or a channel where people can reach you. It could be Matrix or IRC or anything else. And ideally, there would also be public meetings. This is a little bit of an optional requirement, I would say, because public meetings really only make sense when you do have an audience of regular contributors that want to engage with you. So, I mean, offering it and setting it up initially might be nice, but if you discover there's no interest, there's probably no use in maintaining public meetings when nobody joins, ever. But I think this is very good to keep in mind, that the entrance barrier sometimes can be very high and very difficult for people to get into a new project. Yeah, and then finally, sort of the stretch goal, having an open status page, having open logging, monitoring, and alerting. That, of course, implies that you have a way of effectively concealing secrets in logging. So you have to be very intentional in your logging. You need to really know what you log, and don't just print everything to a console and then just open it up to the public. That might be actually exposing a service to attacks or vulnerabilities. But I think it's sort of, if you do it this way, if you open up your logging, then you very intentionally set up your logging. So it's, I think it's just a very good mindset and very good practice. And open incident management, that is really what also Michael talked about, I think 2 hours ago or something, in his talk. Open incident management is a very good practice because there is no shame in incidents. They happen everywhere. There are some really good examples, I think, also from companies like GitLab really having very open incident management. And yeah, I've never really heard anybody laugh about their incidents. You know, it's something that, of course, you're not proud of, but the important part is that you learn from it, and yeah, that you also give others an opportunity to learn from it. Okay, so let's go into an example. This was a gap analysis that we conducted in our team 9 months ago. So we looked at these criteria that I listed for you, and we asked ourselves, how open is our project? What I need to add, I mean, I don't want to tell you what Image Builder is, because Andre very skillfully did that about 40 minutes ago. So the important bit to know is our project is a hybrid project in that it is offered as an on-premise version that is packaged in Fedora and in CentOS Stream and in RHEL, and it's also run as a managed service. So let's put it this way, we had probably an advantage to services that only run as a managed solution. Parts of our openness, I think, come from this aspect. You know, you could always run the service on your laptop or on your local deployment, so therefore you were able to download the assets and inspect the code anyway, and all of our code was on GitHub at all times. So the first requirement was easy for us to satisfy. The contribution workflow was maybe a little trickier, but we luckily had an existing Docker stack that would bring up the entire managed service. Like, you could do both. We have basically a way of setting up the development environment for the managed service, but also for the local deployment. The next one was already a little more critical. So our team is working at Red Hat, and of course the issues that get created on GitHub are public, and of course the issues created on Bugzilla are to some extent public, but we have an internal Jira instance that we use for tracking and planning, and where we create sort of the tasks and the issues that make up for our plans and for our roadmap going forward. And that was still internal at that time. Also documentation, there was a very noticeable gap. I mean, our documentation was there, it was all sort of upstream and also available to RHEL customers, but definitely not about the service. So basically there was some developer documentation that was really geared at people running the thing on premise and running it locally on their computer, but we never thought that it would make any sense to include service-related documentation, because well, our team is building the service, we're maintaining it, everybody else is just consuming it, so all we really need is user documentation. But if you really want to enable anybody else to understand the service, to be able to contribute to it, you need to open up that information as well. In terms of communication, again, I guess we were mostly thinking at the time, it's our team that's working on it. We don't really get a lot of external contributions. Why would we have much setup there? And we basically had an IRC channel, and we said, if anybody wants to reach out, they can. But internally, we were using Slack in the team. And then I remember, I think 1 year after I joined, I hadn't looked at the IRC channel in a while, and then, I looked. And then every time, a day goes by, in IRC at least, there's a line injected. Oh, the day got passed. And then I scrolled up and I saw somebody asked a message, and it was days and days and days and days and no response. It was really weird. And then I noticed that, that's really not, that's not really the image that we want to convey to any type of external contributor, that we don't really care about that. So, that was very helpful to realize that actually our IRC channel was orphaned, and that nobody would really be encouraged of interacting with us if we don't react. And then finally, open site reliability engineering. At that point in time, we had none of this. We had no open status page, no open logging, alerting, or incident management. We hadn't really thought of this at all. I mean, maybe another piece of information. At that time, I think, when we ran the gap analysis, our service was, I think, in production for something like 5 months. It was publicly available. So it was still very early. And that's, I think, why it was also very valuable and great that we were able to tackle these things very early on. So how does this look now? Like, basically, from a couple of days ago, I updated this slide, and I look at all of these things again. So first of all, there's no more reds anymore. There are still things that we're not yet doing, but in aggregate, in every section, we have at least one green check mark. And green and red, for me, makes orange in this case. So if you look at issue tracking and planning, this was a bit of a process. It meant informing the team, informing the business, anybody who interacted with our issue tracker. It is public now. There's, of course, still a possibility to write sort of hidden comments, as there is in Bugzilla or in, probably in any issue tracker, because sometimes you want to put information there that is somehow relates maybe to secrets or to customer information that you don't want to expose. But generally speaking, all of our tickets are open. In terms of documentation, we worked really a lot on our service-related documentation to make it easy to understand for everyone looking at it. How is the service deployed? What's the architecture? Which components are involved? Sort of where are they deployed? How is everything working? In terms of communication, we started by creating a public mailing list, because we figured that if you have to actively look into an IRC channel to get a message, if that's not really part of your routine, then messages may get lost, but everybody somehow looks at email. And if the email pops up in a mailing list, there's a big chance that somebody will see it and will respond. And we also registered a matrix channel. And several team members, were very active and wanted this, so I think it will not be orphaned soon. So one of the remaining gaps in this area is that we still don't have any regular public meetings. But as I said, for me, this is sort of more a thing that is, ideally, we would have public meetings, but then, you know, we'd also have to have an audience. And we would have to have regular contributors. We, of course, have that because within Red Hat, you know, we're collaborating with other teams. We have meetings with those other teams, but we don't really have an external audience yet. And I would hope that this would become a thing. So, yeah, that is the hope. And open site reliability engineering, we have an open status page now. So you can look whether Image Builder is working and running. And we still don't have open logging, alerting, or incident management. I think that we will work on open incident management because I think this would be very valuable and it's very achievable. I am at this point less sure about open logging and open alerting. Maybe alerting, but logging I'm still very uncertain about. I think that would take a lot of effort from our team. Right, so this is the example. I mean, as I said, our team is working at Red Hat, and we're not the only ones going through this process. So this is really an effort that goes across many teams in Red Hat. And this is why I'm particularly proud of the next slide, which shows that on console.redhat.com and in the Insight services, all of these teams have gone through this gap analysis. So these are both screenshots, basically, of the analysis that they've done. You can see there's a lot of greens. There's also a lot of reds. But they're working on it, and this is something that I am really proud of. You know, that generally speaking, people have really understood that message. So when I approached them, they were very happy and very ready, and actually Steph was key in that effort. And so, yeah, I hope that we can get to similar results that we got to with Image Builder with all of these other services. Right, we haven't really spoken about the actual problem that, you know, Image Builder is an open source service. We consider it one, but you probably didn't know, you know, when you entered this room, maybe you knew about Image Builder from Andre's talk or from Achillea's talk, but you probably didn't know that it was open source or how open source it was. So we've defined 4 requirements together with Steph, like how can you make sure that your service, that anybody recognizes that your service is open? So first of all, there is a visibility requirement. If, you know, you should see something, some kind of indicator that lets you know that the service is open. Secondly, there is sort of a criteria of understanding. People should be able, from the reusable thing, they should be able to understand what is the service architecture, what are we looking at, you know? What are the components that make up the service? The third one is actually more tricky than it sounds. It's introspection. Somebody should be able to inspect the code, but not any code, not, you know, your latest Git SHA or your experimental branch. They should be able to go to the exact version of the code that is currently running in production, because otherwise, really, it's a little pointless, you know. You might have fixed things in your main branch already, but maybe for some reason, you know, it hasn't really been deployed yet, and it would be really misleading, you know. It could also mean that if you run into a problem with an API and you want to look into the source code to verify that maybe something's going wrong there, maybe there's no typing or nothing that will prevent a certain error from occurring, if you don't really have the code that is running in production, you might not really get to the answer you're looking for. And then finally, also contributions. Somebody looking at that reusable pattern should find a way how to contribute. Right, that's it. Doesn't sound very difficult overall, I think. And we've tried to come up with something that I will show you now. And if you go to this URL, you will also be able to experience it. So this is Image Builder in Red Hat's console.redhat.com. And at this point in time, and we will be talking about this in the logo poll, this looks very, very integrated. So here you can see a little branch icon that sits up here, and that, you know, if you're sort of a developer or a software developer, you've probably seen this before, and you might think, what does that mean? And if you click it, it tells you this service is open source, and you can explore all the repositories to view and contribute to the source code following this link. I've conveniently opened the link already in the next tab. That's what would happen anyway. But just to make sure that we don't get any network hiccups, let's just jump to that page. So here you can see immediately what is the architecture of the service. You see all of the components that make up Image Builder at this point. You see the front end, you see the back end, that both of those are in the console.namespace, you see that Image Builder Composer is actually in a different cluster. It's somewhere completely different. And then you also see that there's a worker fleet, and there are some databases that are running attached to both services. When you want to go into one of these, when you want to click into one of these components to explore the source code, you can of course click, and you will see that it does take you to the exact hash that is currently running in production. That works for all of the components, of course. So as you can see, this is really this satisfies the requirement of of introspection, of being able to introspect the code that is currently running, and the criteria of understanding. You can see which bits and pieces make up the service, and maybe from your error or from your interaction error, you will already know, oh, this was a front-end error, whatever. I got some weird pop-up that shouldn't be, or the button was 3 pixels to the right, and I really hate that, let's fix that upstream. That would be my reaction, probably. Then, of course, you'd be wondering, like, how can I fix things upstream? And then there's this section that tells you how to contribute. So we have a developer guide. We have actually a development stack that you can set up, both for the front end and for the back end. The back end, of course, includes the entirety of the stack in this case. We have a way how you can reach out to us, sort of the matrix channel, the mailing lists, but also the issues and pull requests. The Jira links are still missing here. I should add those in, but they're also publicly accessible. And then finally, you'll see the assessment that I showed you as part of this presentation also here. So you can see which things we're actually doing and which things we're currently not doing. I'll probably try to improve this a bit over time, and add more hyperlinks that you see that the source code is open, and unit tests, and so that you get a bit of a hint to each of these requirements, how we satisfy them. But at this point in time, I really just wanted to show how open the service is, and make sure that, everybody who finds a gap, or thinks that we don't deserve a green light where we currently have one, raises it with us. That's one of the reasons why we want to make this transparent and we want to expose this. Right. So this is how it looks. This is basically the thing. So a badge that you can slap on your service that makes people understand this service is open source, but that also takes you to a page like this that then explains, how does the service work, which version of the service is running, how can I fix issues in it. Right, and now, as I said, this is just a button, but we did try to make this as easy for you to use as possible. It's really just 3 lines of code. It's a reusable thing. The idea was always to create something reusable, also to make it consistent. You want to have the same experience at all times. It's very easy to write the JavaScript thing that does a pop-up and stuff, and then, every service, the wording is different, or maybe the icon is different, or the placement is different. You really want to have a consistent experience. That's why we started, at least sort of within our organization, to use the front-end components library and just add this new widget there, the open source badge. And as you can see, it only takes one argument, and that's the URL to the page that you want to refer people to. We don't want people to change the wording. We don't want people to fiddle with the icon or anything like this. It should always be uniform, because that is how we satisfy this first criteria of visibility. It should be recognizable. You should immediately know what to expect and how to get it. And then finally, we're at the interactive part of this session, sort of at the end. We're currently thinking of, what kind of branding do we want for this? You've seen that currently I've added a branch icon because that was available in Patternfly's icon library, so that was easy. But we were really thinking, or we were really in 2 minds a little bit. Do we want to create custom branding, something that, stands out, something like the OSI logo that sort of, after a while and after you've seen it repeated in many, many places, you will understand what it means, and it will mean something very specifically. And that would be open source service. And that would be option 2, custom branding. Or should we go for something that we currently have, maybe add some color coding to it just to make sure, to make it stand out, to not make it sort of look too integrated into the service. That's very technical. It's sort of It means something to everybody who's a developer, so maybe it already reaches the right audience, but maybe not. So I think we're a little bit in two minds here, and I would be really interested in, after you've all heard my talk, which option you would actually be interested to see, or which you think would really solve that problem of having an icon, seeing it, and knowing, I've seen this before. If I click here, this service is open, and I can actually inspect the code. So maybe just with a very quick hands up. I know you had very little time to think about this now, but maybe just give me a gut shot. Two of you would go for the option one, basically the known icons, the fork me icons, the generic icons. Okay, that is 15. And who would go for option 2, custom branding? Okay. You're holding both of your hands up? Okay, so that was 15 to 9. That sounds like there's a slight preference for the fork me direction. We haven't really decided anything at this point. I'm very happy to receive more opinions on this, to be honest. But generally speaking, I want to create something very soon that can be reused and that can be shared out through all of Red Hat services and through all of Console initially. Ideally, later on, also, for anybody. It's not really. It's maybe something that starts at Red Hat, but it shouldn't be something that is restricted to Red Hat and to its services. Yeah, and with that, I'm at the end of my talk. Thank you, for coming and for listening to me. And now it's question time if you have any. Go ahead. Oh, yeah.
The problem with option 2 in my mind is that how to establish it as something that people recognize.
Yeah.
Because until you do that, the risk is that nobody will understand what it means, and then option 1 is preferable.
Yeah.
On the other hand, if you can establish option 2, then it's of course better to have something more specific. But until you get there, there's the risk that nobody will understand it. So how do you get to establish it as something known?
Exactly. Thank you. That is the summary of the conundrum that I was facing, where I thought, I'd ask all of you for your opinions. No, it's really, that's exactly the point. How do you want to get the thing off the ground? How do you want to get people to click it and to actually look?
And maybe when open source services becomes more mainstream, that's a better time to try to move to something more specific.
Yeah.
Because then people know the basic concepts.
The thing that I'm afraid of a little bit is, there are other projects that do open source services already. There is like GitLab, for instance, GitHub also to some extent, like some of its code base is open. Even Atlassian shares their code base, not in a very open way, like they don't have a repository that you can commit to or that you can submit changes to, but sort of this concept, it's not new, or it's like and that's also the thing. I don't want to necessarily establish a Red Hat brand. I would rather have something that works for Red Hat, but also for the community, something that can be very easily repeated without anybody thinking, I'm slapping a Red Hat logo on my service. Why would I do that? So I think the barrier has to be low, and it has to be accessible immediately, and you have to understand it when you see it. And that's, I think, the tricky part with custom branding. As you say, you need to first establish it a little bit and have several services on board, which is why I want to have the reusable pattern, because then, of course, we can swap it out at some point. Martin.
Yeah, I want to bike shed a bit of the cost now. Okay. Do you have some practical experience with actual contributors from outside your team that try to read your documentation and then set up the service and send a PR?
Yes. Yeah, that is a very good point. So, of course, sort of.
That seems like the litmus test, right?
Yeah, exactly. So this part actually, we should probably make that explicit here. You have to have at least one contribution, that proves that this is all working, So if you don't, how can you prove that external contributors can follow the same workflow? You need to have a contributor that has done it. So yes, we have had this. In our case, it was somebody from another team in Red Hat, but we've also had many contributions from the public. Maybe not necessarily always to the entire service stack. And as I've showed you in our architectural diagram, there are lower level components anyway that it's very different to contribute patches to those. Also the development setup is very different for the lower level components. You can run them basically on their own. You don't necessarily need to bring up the entire stack that runs in console load. But of course, if you want to fix something in one of our APIs, you have to be able to do that. Otherwise, it doesn't work. And yeah, we have examples for this. Yeah.
Right, and Gary, I know this is something that affected us very much. Like until a couple of months ago, even inside our team, you all had different development environments, and then we had like some more code students come in and try to follow these and come completely stuck. And this is where we said now that maybe they are not as good as we thought, like the documentation.
I think
So
this is
great to hear,
yeah. I think this is why this is overall. Even if the question can always be what's the business value of this whole thing? Why should your employer or why should anybody go for this? Why should anybody support this? And it does make you much better as a team. Like these are the workflows that we're used to, the traditional open source workflows, and they're currently, if they don't work, so for instance in Red Hat at least, I can speak for that environment a little bit. We've broken this paradigm with services. So teams have a very hard time contributing to each other's services because it's not obvious. It's not the same thing anymore. You don't just go simply to the one repository that has the same name as the package and that is in a place where you would expect it. And there are all of these links. Sometimes you have to click through several repositories until you find the thing. First you go maybe to Fedora's package and then you realize that's the upstream and stuff. But there is a way you can sort of retrace the steps, and that's not necessarily the case with services. It's sort of much more intransparent. And then, even across teams, or even when you onboard somebody new into your team, these are just best practices. Initially, when somebody new onboards onto your team, they are like an external contributor. They maybe have no rights because you don't want them to do all of the things already. So I think it's very general, and it's just many of these things are general best practices. They're not revolutionary and not new in that sense, but I think overall they make for a very good assessment of how you're running your project. Any more questions? Because we are out of time, so thank you for your attention, and thank you for that.